Good morning to one and all present here. This is Lakshmi Prasanna.
And this is Chandini.
We, students from Woxsen University pursuing architecture, welcome you to the first Woxsen International Architecture Conclave 2021. Woxsen University is a unique effort that has been designed to reimagine education and learning. Established in 2014, Woxsen University is the flag bearer of the first universities of the young state of Telangana. With a strong belief in creating a highly invigorating knowledge platform that transcends traditional academic boundaries, Woxsen's foundation rests on four pillars: academic excellence, applied learning, global exposure, diversity and inclusivity, which has propelled the university to a stellar rank 4 among the top private universities in India, courtesy Times B School Ranking 2021 and National Impact Rank 8 top private university, courtesy IIRF Education Post, to name a few. Woxsen is creating robust platforms for learners to power through change and embrace disruptive technology, whether in management, technology, design, or architecture. Woxsen is leading a new paradigm in education that has adaptability and resilience at its core.
And now, Prasanna, do you know why exactly are we here for?
Well, of course I do. Aren't we here to take a look at the beautiful construction marvels?
Yes, but not just about the recent construction methods which played a huge role in the economic developments. We are also here to get some insights about some great architectural innovations in the recent times. And now, on that note, we have our Dean for School of Planning and Architecture who played a major role in shaping this architecture conclave. Professor Ramakrishna Bhushi holds a master's in urban planning from the School of Planning and Architecture, New Delhi, and pursuing a research in urban development and management. His subject management information system and professional practice. In his 26 years of academic and industrial career, he has served as a principal, HOD, professor, and expert member for academic audits at prestigious institutions, having extensive experience in curriculum design for architecture and allied courses. Received award for appreciation in the role of vice principal in his previous institution. In the event of the Architectural Journalism Awards held in Bangalore, he was also honored for guiding students to develop the best articles, winning first place in the Green Building category and the second place in the Signature Building category, a national level competition organized by India Today Group. And now, I would like to invite Professor Ramakrishna Bhushi, sir, to give the inaugural speech. Over to you, sir.
Good morning to all. Dear students, eminent practicing architects and engineers, and the Woxsen family. It is a pleasure indeed we all to be present here. Woxsen School of Architecture imparts not just day-to-day teaching and learning process, but also impart a holistic approach to mold the students in a different perspective. Woxsen students of architecture are given a free hand to expose themselves to a variety of co-curricular activities to build the school, so that when a student graduates from a campus, he would become a complete student to the fraternity of his own profession. In this way, the school has undertook the major stride to attain the development in many ways. One such activity is to bridge the gap between institution and industry at a large. That is the main objective of this conclave. At this juncture, I am glad to introduce a distinguished three speakers on this platform for a two-day session. The theme of the conclave is construction marvels and novel architectural innovations of the recent year. So our first speaker, architect Syed Ahmed, is a senior director from the Riyadh, Saudi Arabia. He is going to talk on innovation in architecture. And our second speaker, B.T.Srinivasarao, popularly known as the BT in the fraternity of architecture. He is a senior design manager in Kuwait. He is going to speak on double skin architecture. And our third speaker with us is the engineer A.Soundararajan, is the AGM and head for engineering division from the Eversendai Company Private Limited. He is going to dwell on the challenges in the construction of architectural marvels. I am very confident today the two-day deliberations will be useful, fruitful to the students and architects and engineers. Thank you on one and all for this opportunity. Now, over to Prasanna and Chandini. Thank you.
Thank you, sir. And now we would like to invite Dr. Ahmed Bhadra, sir. Over to you, Chandni.
Dr. Ahmed Bhadra is a strong pillar of Woxsen University, a leading researcher and passionate academician and member of the prestigious Harvard Business Review Advisory Council. Dr. Bhadra adorns these multifaceted roles with commitment and futuristic vision. An alumnus of Indian Institute of Management, Bangalore, he has undergone training for conducting cases and research by Harvard Business School and Cornell University, USA. His expansive professional journey is a perfect blend of academics and industry experience. Under his leadership, Woxsen has successfully launched pioneering business programs in disruptive fields like data analytics and artificial intelligence. He has been instrumental in acquiring the prestigious NBA accreditation and top B school rankings. He has played a vital role in introducing innovative learning methods as well as keeping the curriculum relevant to change in times and also to the industry. While his research interest lies in brand management, sales management, and services management, Dr. Bhadra has published 19 research papers in peer-reviewed national and international journals, including a few in ABDC and Web of Science listed journals. With his immense support, we could establish this architecture conclave. And now, I would like to invite Ahmed Bhadra, sir, to deliver his message. Over to you, sir.
Thank you very much, Chandni, for the very generous introduction. I think I've discovered some facets of myself which I was not aware of. Thank you for enlightening me. It's a great pleasure for me to invite our very distinguished speakers, Architect Syed Ahmed, Senior Design Director, EGIS International, Architect B.T.Srinivasarao, Senior Design Manager, Turner International, Engineer A.Soundararajan, AGM, and Head Engineering Division, Eversendai Construction Private Limited. Dean School of Architecture and Planning, Dean School of Design, Dean School of Business, other distinguished practicing architects, students of other institutes, my own dear students from the School of Architecture, ladies and gentlemen. At the outset, let me tell you that India is known for its great achievements in architecture, not just today, but over the last maybe 500 years. We have some of the most splendid architectural marvels in India, starting from the most well-known monument, which is the Taj Mahal in Agra. And we have the Red Fort in the city of New Delhi, the Qutub Minar, the Gol Gumbaz in Bijapur in the south, several of the greatest forts that the world has ever seen, some great buildings which have come up during the British era. And in the last 70 years in independent India, we have seen so many great things coming up. We have seen so many planned cities coming up. The city of Chandigarh, for example, the city of Gandhinagar, the city of New Mumbai. So many planned cities, so much of great architecture that has come up in the last 70 years and of course in the last 500 years. We can really be proud of our architectural heritage. Behind all of this is the unseen professional, who is the architect, who works behind the scenes. People marvel at the buildings. They don't realize that it has come up because of the talent, the hard work, the creative abilities of the architect who's behind the scene. Everybody knows the Taj Mahal was built by Shah Jahan. Nobody knows who are the architects who built it. So the architects are the unsung heroes. But today things are changing. And today people know who the architects are. People like Charles Correa or Lutyens, or people like um, Louis Kahn, who built the city of Chandigarh, I think. So today architects have become celebrities and they are well known. And I'm sure that the students who are entering this profession today have a great opportunity to build a name for themselves and to build a splendid career for themselves. While we have come a very long way in the last 70 years and in the last 500 years, we have a very long way to go, because India is still in the developing stage. I don't know how many of you are aware of the fact that we still have more than 630,000 villages in India. And these villages are like small hamlets with populations of maybe 1,000, 2,000, 5,000, 10,000. And these 630,000 villages are one day going to become towns, and they're going to have proper buildings and proper construction. They're going to have residential buildings. They'll probably have shopping malls. So the task of building this country is humongous, and behind this is going to be the Indian architect. In the next 10 years alone, more than 400 airports are going to be built in different parts of the country. And that itself is a humongous task. In the next 10 years, we are going to build something like 20,000 kilometers of roads and highways connecting north, south, east, west, the Golden Quadrilateral, and many other things, ports and major towns, and so on. And as you know, some of you are from Hyderabad, you would have seen the ORR, which is today such a beautiful piece of construction. It came up within a few years, around I think 2009, 2010. And around the ORR, you can see so much of construction, so much of architectural marvels coming up. So imagine when you have 20,000 kilometers of roads and highways, what kind of construction, what kind of new architecture is going to come up. We are going to have residential complexes, we are going to have commercial complexes, we are going to have malls, we are going to have export promotion zones, we are going to have manufacturing complexes, and so much. And all of that is going to be built by young people like you who would be practicing architects at that stage. And the time has come when each building is an architectural marvel. We used to talk about a few buildings that I mentioned, like the Taj Mahal. But today, if you go to the city of Hyderabad alone, you'll see so many buildings which are so beautiful, they are architectural marvels by themselves. So I think there's a huge potential for young people who are building their careers in the field of architecture to prove themselves. One great example that I can cite is the Woxsen campus itself. I'm sure all of you know that Woxsen campus is an award-winning architectural marvel, I can say. It's one of the most beautiful complexes, university complexes, which are there in India. People talk about, the IIM building or the IIM Ahmedabad building or the IIM Bangalore buildings. I think our complex is no less than the IIM Ahmedabad or the IIM Bangalore complexes. It is certainly an architectural marvel. It's beautiful. And in the last 1 year, it has become even more beautiful after we became a university. There's so many new things which are coming up. And in the next 5 years, the whole area is going to be completely transformed. So I'm sure the Woxsen campus will be a place where people will come. It would be a tourist spot. Already 5 movies have been shot in the Woxsen complex. I'm sure in the years to come, when people visit Hyderabad, they'll make it a point to come to the Woxsen complex and see, oh, what a beautiful thing it is. Just outside my office, I can see the new library building, which is a 40,000 SFT building, one of the most beautiful buildings, I think, in an education environment I have seen in my life. It's so beautiful. So I think there's an enormous scope for architects. There's a huge amount of work to be done, and all of it is going to be quality work. And we have new construction techniques, so you can really build something very, very, very fabulous. Our objective here in the School of Architecture and, of course, in the university is not just to produce great architects, people who are technologically very accomplished. Our objective is actually to produce individuals who have all-round abilities, not just people who can produce great architecture, but people who can actually conduct themselves professionally. They will be great professionals. They'll have a sense of discipline. They'll have a sense of ethics. They'll have human values. They will know how to help each other. They'll know how to support each other. They'll know how to build teams, and they'll know how to build a leadership, how to lead teams, and how to create new things, maybe new cities, new buildings. So how they're going to build something which was never there and something that nobody ever imagined. So we want to create professionals who are well-rounded individuals, who speak well, who have a sense of fair play, who have a sense of ethics, who have a sense of human values. And that's the kind of thing that we are trying to build. And we are trying to introduce a number of things in the university which many other academic institutions do not have. The ability to participate in competitions, the spirit of competitions, the spirit to excel, to spirit to learn. That is what. So we want to produce people who are more than technical professionals, but people who are going to really take this country forward. And I'm very confident that with the brilliant team of the professors and with the support of some of the most outstanding professionals, like the speakers who are gracing this occasion today, and many others, with the help of each one of you, we will be successful in building this school and this university. And my appeal to our students is that please make the best of the opportunity that you have currently. It's a 5-year window that you have, and you have to make the most of it. Take advantage of it. Put in your best, and I'm sure you will flower into great professionals, great human beings, great leaders, great team builders. And I'm very proud of the School of Architecture and students of the School of Architecture and Planning. I've been interacting with them for the last 2 years, and I think they are the most, most committed and most sincere and most dedicated bunch of students I've come across. There's no doubt in my mind that they'll flower into exceptional professions. And I congratulate the faculty team for having led the school so well, and I congratulate Professor Ramakrishna for having taken the initiative to have this conference. I congratulate Professor Ajay Sinha, who has been a great guiding force for the school for the last 1.5 years. And with that, I think I'll conclude my talk. Wish you all the best for this conference. Student volunteers who are guiding this, thank you very much for helping us out with organizing, and wish you all the best, and thank you very much.
Thank you so much, sir. Thank you so much for your immense support and great insights. And now, I would like to introduce Dr. Raul V. Rodriguez, Dean of the Woxsen School of Business, Pro-Vice Chancellor, Woxsen University. Dr. Raul V. Rodriguez holds an MBA, MHRM, and MSc in Big Data and BI from Universidad Isabel I, Spain, and has completed his PhD in artificial intelligence and robotic process applications to HR from San Miguel University, Mexico. Dr. Roll has been nominated for the Forbes 30 Under 30 Europe 2020 list and an awardee at the 40 Under 40 Europe Indian Leaders. Alongside this, he's a regular keynote speaker and panel moderator at various national and international conferences or summits. Additionally, he's a member of the Harvard Business Review Advisory Council, the Oxford Artificial Intelligence Society, part of the University of Oxford, and the Institute for Robotic Process Automation and Artificial Intelligence. He has co-authored 2 reference books, New Age Leadership, A Critical Insight, and Retail Story, and has more than 70 publications to his credit. He is a weekly contributing writer to various magazines in the field of analytics and emerging technologies, as well as journal reviewer and associate editor in various publications such as IEEE. Over to you, sir.
Thank you so much for the introduction and having me here. Everything has pretty much been covered, so there is nothing I can really say that is going to become insightful, motivational, neither remarkable. However, I'm going to cover only 2 perspectives. One is, how do I see architecture from an international viewpoint, coming originally from Spain? At least that is what my passport says. I don't know anymore, but this is what my passport says, and from there. And secondly is the international approach to the university as well as the School of Architecture. If we cover the first point, I'm sure most of you might have come across various architectural marvels. We spoke about India. Obviously, one important aspect of comparison is Western Europe or the southern areas of Europe. If you talk about Spain, I had the opportunity in the past to visit the Guggenheim Museum in Bilbao in northern Spain, the Sagrada Familia in Barcelona, a marvel by itself, a huge cathedral, as well as I'm sure most of you know Antoni Gaudi as an architect and what he's done in the past. Now, this culture of mix of Gothic infrastructure with the modern times is spread across all the Southern European region, namely Spain, Portugal, Italy, Greece up to a certain extent. So keeping this in mind and considering that this is important and it's critical across disciplines, and especially in architecture, to understand and comprehend what other countries or other cultures or even other societies have done in the past, we have taken a quest at the university to internationalize every school to a certain extent, of course. Internationalization does not mean just to call international speakers or professors or even do international conferences. It also means to bring that value proposition on the table. And that value proposition comes with exchange programs. If I see each of you here, I'm sure you all will be interested to go to, let's say, for example, touching base again, Spain or Italy for maybe 6 months to 12 months and explore their architecture in one of the universities. Currently, I can tell you we have 2 partnerships, one in Brazil and one in Georgia, Eastern Europe. So these 2 universities are more than willing to host architecture students. There is another partnership right now ongoing, which will be finalized shortly in the southern area of Spain, in Granada. If you have heard about the Alhambra, which is a huge infrastructure, Muslim-based infrastructure, when Spain was colonized in the long past by Moroccan army at that point in time, there was a mixture of cultures in Spain, and it still is there. And you will see that that happens across all the European Union there because of course, the historical changes that took place. Understanding this, going there, spending time there, speaking to the architects, to the students, researching upon it, I believe that will be at the very least rewarding. It will, of course, enhance your perspective. Ultimately, it will make you better individuals, better citizens, and obviously better professionals, which is what we're aiming at. So when there is an international conference, I'm always very excited because ultimately this is one of the pillars of Woxsen. This is what we have aimed for and shot for. And this is what we are aiming at. And obviously these partnerships are there to be activated. That means that we need to actually do send students and do host students as well. India has I could say, a much richer architectural culture, as the Vice Chancellor rightly said, that most of Europe could claim. And bringing international students here could surely become very remarkable to them. Unfortunately, many of them will only want to visit the forts and probably Taj Mahal, but obviously we have to open their horizons a little more and make them explore different dynamics of the country. So this is what we are aiming at, and this is what our focus is, internationalization across. And architecture is a field where if we don't have internationalization, we are going to be lacking a huge pearl in the learning process. Because all of you are studying international marvels, I'm sure of that. Most of them, believe me, it's much better to see it in real life, explore it, even touch it, than just seeing it on a book or online. It makes a huge difference to your own perspective. And I have met many Indian architects in the past who have, during their education, they went abroad and their overall perspective changed radically. They started seeing a new reality of their work. And many of them ended up in the UK, in France, even in Portugal, and they're currently living there. So I've met them in the past, and that has happened. And I've seen the change, especially in this field. So as the opportunities arise, and they will arise, they're already coming up, in fact, and the team at the School of Architecture is putting great efforts also to push it in that direction. Just my advice to you will be, take it, don't look back. Students tend to become hesitant when there is an opportunity to go abroad. They do want to go abroad, but then the fear, or maybe the staged fear of going to another country, another culture, another language may become threatening, but it has not any type of menace to it, because ultimately, even if there is a different perspective to life, architecture is going to remain there as a main common spirit to all of you. And that is what you have to grasp from that particular country or individual. So from our end, from the university end, you can have the certainty and the commitment that when it comes to internationalization in particular, because we are an international conference, we will be committed, we will deliver. And obviously it's a two-way street, so students also have to be on board for it and have to push the best effort they can in order to enhance the capabilities of the university and themselves. And with this, as I told you, there will not be anything too motivational or remarkable for me to say, but nevertheless, I believe this point summarized from my perspective. So thank you so much, and I wish you a great conference.
Thank you, sir. Thank you for your immense support and for your time today. And now I would like to invite Professor Ajay Sinha, sir, to introduce the first speaker of the day. Over to you, sir.
Thank you, Chandni. Before introducing the speaker, I would like to thank the VC for his kind words, and also the Pro Vice Chancellor, Dr. Raul, for giving us the opportunities. We'll certainly take it and will not look back. We'll certainly do that. Thank you, sir. Moving on to the speaker, Dr. Syed Ahmed, Professor Syed Ahmed has done his Bachelor of Architecture from College of Fine Arts and Architecture, JNTU, and has got his Master's in Landscape Architecture from School of Planning and Architecture. He is a recipient of the Gold Medal in BR 1987 and has been a recipient of National Merit Scholarship from 1981 to 1987. In addition to this, he is also a lead accredited professional and also a project management professional. His work experience encompasses design and management experience in the fields of master planning, landscape architecture, infrastructure, and construction supervision. His prime work responsibilities include preparation of landscape design, tender documentation for large master planning and landscape projects, preparation of RFP, that's request for proposals, for solicitation of bids from the shortlisted contractors. And he has played a key role in proposal contracts, design and management of several joint venture high-profile projects with international consultants such as L&O from Hong Kong, HOK USA, SWA USA, Foster Press Partners UK, Bureau Happold UK, Canon Design USA. And he started his journey from being a landscape architect at Ravindraban Associates, New Delhi in 1991, and has moved up the ladder and is presently the senior design Al Akaria in RSA. And some of his key projects include Security Forces, Medical City, Riyadh and Jeddah, where he worked as a specialist consultant, and King Abdullah Housing for MOH, where his role was a project director, Ras Al Khair Industrial City as a project director, then King Faisal Specialty Hospital and Research Center as a project director. And other than this, he has also received the Best Hospital Design Award. He was from UAE, Dubai. And along with this, he was also kept in touch with his academics, and he has been giving seminars. As he has delivered webinar on xeriscape and sustainable landscape practices to Department of Landscape Architecture students, School of Planning in Delhi. He has also been actively involved and worked as a guest faculty and jury member for professional training for students of Vaishnav School of Architecture, Hyderabad, and also xeriscape sustainable landscape practices in Riyadh, Kingdom of Saudi Arabia. So we are very happy to host you, sir. And over to you, Prasanna. Sir, you can take this from here.
Thank you, Professor Ajay, for a nice introduction. I would like to thank Dr. Amit Bhadra and Dr. Rahul. They gave very nice input. I am impressed with Dr. Amit Bhadra about his knowledge about the architecture and appreciation for the Indian architects and Indian architectural monuments. Quite often, this is one of the best area where we can see different kind of architecture in different regions. It's more sustainable than what we are currently doing in the modern architecture. And also, like Dr. Rahul says, there are a lot of things happening outside the world, which is much more interactive and more creative ways of handling the public realm and how the cultural aspects have been imbibed within the design aspects. These are things which we can learn from the international architects, especially when you're working with 4-stars and other big names. They know how to work with the local culture and also try to bring innovation so that there is a perfect balance between the projects wherever they are doing, whether it's Saudi Arabia or America or different parts of the world. So having said that, I would like to just start a small presentation so that the main idea is, as I understood from Professor Ramakrishna, that this new college, the students are in the 2nd and 3rd batches now. So I didn't want to go too much in technicalities, but the whole focus, what I'm trying to achieve is to give a very broad picture, to open up your mind so that you don't really fix to one direction. You should see the possibilities, how you can start developing the design ideas, creative ideas coming to different areas. So kindly allow me to share the screen. So I think is almost like one hour is given to complete this lecture, and let's start now. You must be wondering, to looking at this slide, this is nothing to do with the architecture. You're talking about the human body temperature. Normally, the healthy person temperature is around 98.6. If the temperature rises, what happens? We call it a fever. So 1 degree increase in temperature makes a lot of difference in the health and well-being of a human body. Similarly, if we consider, look into the big picture, the planet, what happens if 1 degree centigrade increases? It will be a disastrous effect. So I'd like to bring to your attention that for the past so many years, the global surface temperature has been reconstructed based on the proxy data. How did they get this? They got it from the tree rings and the corals and ice cores. So if you see that almost 2000 years ago, the temperature is mostly not big variation. However, from 1880 onwards to current to 2020, you can see the red line, which the temperature graph is going very high. So what is the reason for this? Why the temperature is increasing so much? Also, if you see the NASA data, it shows that land surface temperatures are increasing compared to the ocean surface, which is also increasing, but not substantially. So this is very alarming situation, what we have now, looking at the global scenario. Of course, you can understand that we are talking about the climate change, which is going to impact the environment. Some of the adverse effects of this climate change is like affecting the ecological balance of the coral reefs, or it could be extreme drought, which can also lead to the forest fires and landslides due to the permafrost thawing, and also habitat destruction. And also, when there is temperature changes, the mild winters will allow more beetles to survive and kill large swaths of forests. And some of the environmental mitigation, like rainfall effects, which leads to desertification. Also, sometimes the flooding can happen. So these are all the ill effects of increasing the temperature globally. What are the main reasons for increasing the temperature is the human activity. If you see the website, gas, oil, coal, and land use activities, these are all contributed to the rise. Due to the increase in carbon dioxide, as you know that the greenhouse effect, the global warming is taking place. So on the right side, you can see approximately how, based on the projections, if we don't control the CO2 emissions, and by 2080 it can triple, so that might lead to the increase in temperature of 6 degrees Celsius. So that is quite alarming. So if we start working in the direction of how to reduce CO2, there is an estimate by 2090, if we bring it to drop to zero, then this will be the scenario. So there won't be much impact on the global climate. So the main contributors for the CO2 emissions are the buildings. You can see that almost like 700 to 800 metric tons of carbon is being generated on an annual basis. Then transportation and industrial sector, these are the major activities on the land which creates this CO2 emissions. And also the energy consumption by the buildings, industry, and transport, it also has a huge impact on the global warming. So again, you can see here, it's a 48% of the share goes to the buildings in terms of energy consumption. Of course, these figures will vary a little bit plus or minus over years, but this is approximate figures. So as an architect, when we are doing the new projects, all this, are we really polluting the environment? To a certain extent, yes. And at the same time, as a responsible architect, we should see how we can find solutions for that. So one of the climate protocol in 2015, there are sustainable development goals have been generated by the United Nations to combat the global warming and others to increase the quality of life. So there are several goals set. The objective is by 2030 and 2040, most of these goals should be attainable. So among them, not all are related to the architects, but there are certain goals like industry innovation, then sustainable communities. All these, wherever we need to, our involvement is there, we need to see how best we can contribute in helping the environment. So for example, goal number 9 is industry innovation infrastructure. So on the left side, you can see the challenges. What are the challenges we have in terms of infrastructure and what are the solutions. Like poor infrastructure is a major barrier for good development. So we need to develop innovative and green infrastructure which can sustain for a longer period of time and which has less or no impact on the planet. Similarly, environmental degradation. So we'll have to have a resilient infrastructure to be created for that. Then sustainable communities. Also, due to rapid urbanization, a lot of, especially if you see the slums in Mumbai and other major cities, due to migration, a lot of slums are being developed and they're not being tackled properly. So we have to find solution as an architect at each and every scale, the small scale buildings to large scale buildings. And most of the cities, like they consume almost 80% of the energy, as well as they generate 70% of the global waste and carbon emissions. So again, we have to see how responsible we can to manage our energy resources and usage of the energy. So like I discussed earlier, the global warming is one of the major issues, then storms and floods. So as an architect, we have to find solutions in a more sustainable way. Similarly, to deal with the desertification and saving the biodiversity, all this happens at different levels of the involvement of the architects and landscape architects and engineers. So in a nutshell, the climate change is everyone's crisis. As an architects, we are equally positioned to help solve it. So the American Institute of Architects, they call on architects around the world to support humanity's collective call to climate action through an unrelenting commitment to sustainable and resilient design. Designing and constructing buildings that diminish greenhouse gases are architectural imperatives. Again, designing and constructing buildings that support health, safety, and welfare are ethical imperatives. So we have to see both architectural as well as ethical, and also, of course, the cultural issues. Everything has to be looked into that. So as a professionals, we have the responsibility to prioritize and support effective action to exponentially decelerate the production of greenhouse gases. So by 2030 or 2040, we should be able to control the emission of the gases. So how we are doing this? It is by sustainably designing the buildings. So it is our responsibility to work globally to reduce operational and embedded greenhouse gas production, passive design techniques. Passive design techniques, again, like I said, most of the previous Indian projects and monuments, they're all designed based on the passive design techniques. There are no active machinery used for cooling and heating. Then employ energy efficient measures, adopt existing buildings, how we can, instead of demolishing the old buildings, how can we conserve and reuse it in a more responsible way so that we really have very less impact on the carbon footprint. And at the same time, we have to look into the business and financial aspects to make all these projects viable. So in this direction, what happens is sustainability is one of the key movement which has generated. There are now we can at this point of time we have various sustainable rating systems. I'm not going to list all of them here. Basically, BREEAM, it was UK based, started in '89. Then we got LEED in '94. A.Soundararajan is mainly for the UAE. So there are different, even India also we have green rating systems. So these are all focusing to reduce the carbon emissions and create a good quality of life. So among them, the LEED has taken over and has a quite wide market range and reach within the globe. Some of the credits which I can talk about here is how we affect the transportation, energy, indoor environmental quality, water efficiency, sustainable sites, materials, how we are going to use the materials. All these are very important in the sustainability. So this is a map which shows how many projects are happening or happened within the LEED ratings. So you can see there are a lot of red within US and Europe, and slightly less within the other parts of the world. India also, we can see a substantial amount of buildings. So there is a lot of movement which has generated in the direction of sustainability. So sustainability and innovation. Innovation is one of the rating criteria within the sustainability. So innovation is what we are doing is to implement the ideas that result into introduction of new goods or new services. How best you can make the building very efficient, how you can help to improve the quality of life of the users. This is what is required. In general, innovation is distinguished from creativity by its emphasis on the implementation of creative ideas in an economic setting. So we have to achieve economics in terms of not only the cost, the material usage, and the operational maintenance, all these aspects, so which will have less impact on the environment. So usually for any innovative process, there are 3 stages. You have to have idea generation. Then once you get an idea how to solve the problem, and then implement it. So these are the 3-step process, which as an architect, we generally use it, but to go beyond the level, so like for example, 1 + 1 is 2, that is simple mathematics, but how can we go more than 2? Or so that is what we have to see in the innovation. So I selected a few examples to illustrate how the architects are working to help the environment and to achieve more than 2. So one of the projects which is in Singapore is Intl. This, you can see that's quite interesting configuration of the blocks arranged. This is like a 8-hectare site with 1,000 apartments to be built for 1,000 residences. So initially, on the left side, what you can see is a cluster of high-rise towers, which should have been possible as per the building bylaws, local regulations, which allows. So if this way it is built, then you don't have enough of green space, and you'll be looking into each other buildings. So there won't be any privacy and a lot of issues. So the architect is Wal Sherin. He has come up with a new idea of turning the blocks in a horizontal way and rearrange in a stacked form the hexagonal grid. By doing this, what has happened is you can see the terraces has been created where the usable open space has increased tremendously. Also, that creates open pockets so that you don't feel that you're claustrophobic within the cluster of the buildings. On the picture on the right, you can see one of the terraces at the 13th floor. So here, you see mathematics. The areas, the landscape area after the buildings is around 66,000 square meters. But the sky gardens, they almost have around 23,000 square meters. So put together, they have achieved 112% of green, which is much more than the actual plot area. So this is one of the key innovative ideas how to bring in the project. So this is like one of the benchmark I would suggest as students you should think in a different way how best you can use guidelines, local bylaws, and then improve upon that to achieve more than what is required. So this is the same project with the aerial view. You can see how the blocks are arranged in a hexagonal manner, which creates more open and lively environment. Again, this diagram shows the shading studies. The blocks are designed and located in such a way that most of the courtyards are well shaded and they provide relief. So the configuration of the blocks and how you place them, how you orient them is also very important. Of course, taking care of the sun movement. Again, the same project, how the water bodies and the wind directions. So you have to study the wind, the movement, how the water evaporative cooling is affecting the courtyards and improving the microclimate. This is another project which I have selected. This is designed by Foster Partners. You must be aware of this project. It is Apple building. So again, if you see the site on the left side, it was initially having 24 buildings and 50% of the asphalt area, then very little space left for the landscaping, 20%, because we have a lot of parking areas. And the total, we are almost like 1,000 trees within the site available. And it has been catering for 8,400 people. When the new master plan has been developed by Foster Partners, they try to minimize the buildings and increase the landscape area. So it looks like a forest. The building is within the forest. It's not only giving the form, also it looks like a satellite placed within the dense Amazon forest. That will create a very nice microclimate, and also it reduces CO2 emissions. It absorbs a lot of CO2. Even the building has been designed as a naturally ventilated. If you see there's a cross section of the window where the winds will be coming, and through this aperture where the cooling or heating can be controlled, then the fresh air gets into the buildings. So there's a lot of fresh air within the building and a lot of daylighting and the nice views of the greenery. These are the innovative way of designing the buildings. And one more example which I would like to share with you is the Ar.Syed is a Danish architect who is practicing in different parts of the world. Is one of the waste to energy power plant. Usually the power plant, when we are using the waste, so it's just like a building not to be visited. But here the building has been designed in such a way that it has become a part of the educational project. In Denmark, they don't have any hills, but they have the snow. So he invented an idea, why don't we use the size of the building in such a way that you can use a roof for the skiing. Also, you can see in this picture how the roof has been used as a nice skiing slopes, and also the wall climbing, trekking. There's a lot of activities. So the building has been created as a multifunctional. At the same time, it's producing energy out of the waste. So these are the ideas. Once you start looking into how you integrate the local requirements, the functional as well as the cultural requirements, and creating something new which is not available. So these are one of the best examples for the innovative architecture. Again, one of the projects which is developed by a big team is cargo containers. They build a student housing. Is like a modular one. If this can be used, 3 containers, which is developed on a floating dock. This has been built somewhere and brought to the site, and it has been installed here. So the idea is low cost, quick construction, and as well as when there is a shortage of land, you can expand into the water. So this is like one cluster which is self-sufficient with the solar energy generation as well as natural cooling. So this one cluster, if you see, has been joined together to make a cluster of buildings. And this has been anchored, if you see in the section. So in the lower part, which is sunken in the water. They have the hydroponic gardening inside, and the upper level is a 4-story structure made out of wood. So the materials what has been used is also innovative. We really don't need to use always steel and concrete. So this is one of the concepts which we need to expand these clusters as like a floating city. How we can do that? So these are one of the different concepts where is sea level rising there. So we design to mitigate those effects so that we can actually get a floating city. And this is one project done by Atkins. It is in Bahrain, in the Middle East. So here they tried to introduce windmills within the building. The 2 towers have been connected through 3 bridges. And then we have the windmills. Of course, they will generate around 11 to 15% of the needs of the project. The buildings have been designed in such a way that the wind funnels in the V shape, so that creates enough draft for the wind tunnel, windmill to work. So all over the world, architects are trying to see how best we can utilize the current technology in terms of construction methods, available materials, and how to mitigate the energy consumption is less and carbon footprint to be reduced. This is another view of the same project. Then there's one more recent project which is done by Gensler, which is now it is second tallest building in the world. The first tallest building, I think all of you must be aware, that is in Burj Khalifa, which is in Dubai. It is 830 meters. The second tower, which is in Shanghai, it is 632 meters. So what is the specialty of this tower? This tower has been built with a unique shape. If you see that it is not any regular shape, it has been twisted to create a less impact of the wind. So when they did the wind tunnel testing, they tried to optimize the shape and the rotation. So that way they could save nearly 24% of the energy and the cost. So almost like $58 million have been saved just by shaping the building in a proper way. So there's a lot of engineering has been taken place, especially the wind engineering and the forces, how it will be designed. So there are some of the models which shows you how the structure is stabilized and the rotation of the tower has taken place. And again, it's a double skin building where the outer skin is quite translucent, so it also reduces heat gain. So this is one of the LEED platinum buildings. And coming to the projects within Saudi Arabia, this is one of the projects which we work with Norman Foster. It is Haramain high-speed train stations. There are 4 stations within Saudi Arabia, starting from Makkah, Jeddah, Medina, and Rabiq. These are the stations designed in a prototypical way, but slight variation in terms of the colors and whether it's a terminal station or a passage through station. If you see here, the culture, Islamic cultural aspects have been taken in shaping the forms, but at the same time, the daylighting has been achieved, the minimum perforations within the roof as well as in the fenestration. So during the extreme hot weather, where during summers it can go up to 50 degrees, 45 to 50 degrees range, still you don't need too much of cooling here because of the high ceilings and the limited perforations. This we worked as a collaborative architects with Fosters and partners. This is one of the stations in Jeddah. Again, all the outdoor activities, the connection bridges, everything is fully shaded to create comfort, and there are a lot of landscaping well developed in this area. this is another project, the healthcare project, which we have done in association with Canon Design. Canon Design is a healthcare specialist, and we are the joint venture partners with them. So this is one of the existing hospital where almost like 70% of the site is fully developed. So we hardly have much space left for designing and locating the new program of the Biotechnology Center, 330-bed cancer care hospital, and VIP wings. So here we try to see how best we can orient the building, and also there was a parking all along the surface. So this parking has been removed, created more green areas. All the parking has gone to the 3 levels of basement, which is again naturally ventilated. So very less interaction with the mechanical systems. Also, there is a 1.4 kilometer long tunnel internally, which is supplying all the utilities, infrastructure services, and food supplies, pharmaceutical supplies. Everything is happening there. So this is one of the projects within the King Faisal Hospital, which is yet to be constructed. This is Biotechnology Center. So here the main idea is to create more healing environment for the hospital. This is what has been created. The surface parking, which was there earlier, has been all removed, which is taken down to the basements, and all the surface has been created for the nice green landscapes. So this is one of the award-winning projects. And apart from the large buildings, we also work on the large master plans. And this is one of the race course. Here, the main challenge is to create enough water for the plantation, as well as maintenance of the desert plants. This is a world-class race course of 3 kilometer long race course. And the buildings were designed by Hong Kong-based land architects, Lee and Orange. And we did the master planning and landscape. Here, the innovation is basically when you are looking from the grandstand, there are a lot of sandy winds because the surrounding area is quite a desert area. Always there is dusty sand coming up. So to create a kind of a backlot, there is a huge small kind of hillock has been created, and with the plantation that will mostly filter the winds which is coming to that area. So in a nutshell, what I was trying to say is, whatever project you are doing, you should try to see the local environment and see the technology available, the material available, how you can use it in a best possible way. I could not show you many other projects which are quite small in nature, but it doesn't need to be only leading to the big projects. Even small projects, innovation can happen at any scale, right from the furniture design to interior of the house, to a small community or big projects. So at each stage, when you're designing, make sure that how you can excel, how you can introduce something new, which is more sustainable, more economical, and easy to maintain and develop. This is what the focus should be as a students of architecture when you're designing the buildings. I'm not going too much in detail of the technicalities. So basically, I want you to start looking into the big picture of how we are helping the environment. So that 1 degree temperature increase, what's the impact? So how we can take care of our planet to make it healthy so that we'll be living in a sustaining longer period of time. So if you have any questions, I'll be glad to answer. Thank you so much.
Thank you, sir. Thank you for this wonderful presentation, sir. And thank you for, again, making it a point to how to creating awareness on that 1 degree temperature was a very solid point, I suppose. So we need to start looking at that 1 degree, how to reduce that 1 degree. It will make a whole lot of difference. And thank you for letting us know about the innovations in architecture. And I think this is rightly needed for students who are just starting out, the first and the second years. Start off from here, it's always good for them. And thank you for introducing to some of your projects and also projects from the other architects like Intl or Foster's, and BRK has been, we have been discussing BRK a lot in our sessions also. And there's one project which we did actually have a look at, but we'll definitely cover that project also, BRK's. And cargo containers is one of the time problems which we are trying to give even to the first or the second years.
I see.
So, thank you, sir, for giving thank you for giving a heads up. I mean, things like this are there, so you also can try and do something. And your projects like working with Canon design and HHRS, I think there was a whole lot of innovation also involved in that. And we would actually like to, it's like I was waiting to hear more from you, but since I think it was only the first and second years, and you might have to cut it short. But I do hope in the future we are going to hear a lot from you, sir. And definitely we'd like to be more associated with you. We'll definitely keep in touch, sir. I mean, in the future, of course, depending on your time and availability, we'll definitely.
Sir, it will be my pleasure.
Yeah.
Because
yes,
like
sir.
I said, I didn't go too much in detail of the project, what we have said. I just give a overall broad picture so that the main idea for the student is to think out of the box, how best they can adapt to the environment and look beyond the thing that is.
Yes. Sir, I'm taking this liberty as a personal note. I'm also an alumni, and I know it has been a very hard time for Syed, sir. The past few months, he has lost people very valuable to him in this pandemic. But he was brave enough and he agreed to go ahead with this conclave because he had committed ahead of time that he would go ahead with this conclave. And I sincerely thank you, sir. Thank you very much for this and attending and making it a success. So thanks a lot. Okay, sir, now it's open for question and answers. Like you already covered, the first question is my role, sir. I mean, I would want to start with my role first. You have covered a lot of projects and you also said in a small scale also you can do. But since we are going to start off at a small scale, even the students are going to start off at a small scale, they might not immediately jump to a bigger scale projects. How best is it to approach when it's a small scale design? I mean, in your words, in your experience, some examples of how to approach
small scale.
Yes.
Like I did one project for the school, which is where it started with the 3 villas were there. Initially, the client started to have one of the villas to be converted, demolish the building, and come up with the school. Probably I will share that at a later stage. I don't have immediate access for that. But even for the small buildings, what is important is how best you can bring in daylighting. Daylighting is very important. It's good for our health and also the views to the sky and the greenery. These are the 2 important things. And then the construction techniques. What are the materials available for you? Is it steel, concrete, or wood, or bamboo, or whatever? Because you can use any of the materials depending on the project cycle, how much you want. Is it a 20 years project, 50 years project? How long you want to have this project to be? You make use of that. So you can select the material. You can then again the orientation of the buildings, how best you orient within the given site conditions. So you have to study what are the adjacent buildings, what are the setbacks, and how best you locate the building. And whether you want to create a courtyards, secluded courtyards, or more open spaces. So this is part of the site planning process. Sorry. So this is the process where, like I said, it's principles are same, whether it's a small building or a big tower. Ultimately, we have to go with the daylighting, natural ventilation, cooling, less impact on the energy. So if you have a lot of daylighting, you don't really require electricity, and also if it's oriented properly with the thermal walls. So you don't require too much of heating and cooling. Also how you place the plantation during the summer and winter, the deciduous trees, in winter can give more sun rays can allow the building to enter, and during summer it can shade. So these are the concepts which are applicable for all the scales. There is a small individual building or the complex. Like one of the projects we are doing for the large housing complex, it is like 7 million square meters of the land development, almost like 70 hectares. It's quite huge. So here we try to see how to utilize the natural drainage, use them as a parks, and then the buildings will be facing those. So these are all part of the site planning process. We can start looking into that. I hope I answered your question.
Yes, sir, thank you. I hope the students are getting this also. On behalf of the students and faculty, I have a few more questions for you. They put it in the chat box. The first question is from Abhinay Sriram, is the first semester student. He's asking if architecture actually causes pollution, and what kind of pollution does it cause, and how can we prevent pollution caused by architecture?
Sorry, I didn't get the question. Architecture?
Does architecture cause pollution?
Yes.
Does it cause pollution? What kind of pollution and how can we prevent it?
See, this is a very interesting question. It can create different scales. Suppose if you are extracting the stone from the quarry, what is the process of quarrying? You are just quarrying without any taking precautions for dust production. So that's one way of handling the material from the source. Even during construction, if you are taking care of the leveling the ground, even the lead site, sustainable sites, there is a requirements how to reduce the dust generation, how you have to water the area so that you don't generate a lot of dust, which is leading to asthmatic and other problems. So in each activity, there is a environmental impact. So we have to be sensitive enough to take care of these issues so that we don't really generate pollution. Again, at a larger scale, the carbon emissions, like when you're manufacturing the bricks, how do you do that? You burn the bricks. So the amount of energy used, that's also part of the pollution. So if instead of burning the bricks, clay bricks, if you're using it, of course, we have to look into the structural aspect so that pollution is reduced. So this different levels of pollution happens at various stages of the construction process. Yeah.
Okay, thank you, Abhinay. I think to some extent it has, sir has answered your query.
If not, let me know so that we can discuss
we'll come back to him. He'll have some time to think.
Yeah.
Sir, and then there's another question from Shreya Ajay. She's also she's the second semester student, first year, second semester. Yeah. She has increase in temperature is also causing rise in sea level. So she wants to know what is the future of architecture for that, as it will transform human societies and the way of living.
Yeah, one is first we have to see how to control increase of temperature. Suppose if it is still the water rises. So like I showed you one of the examples of the floating cities. That could be one aspect. Like one of the project of the big also, like in the New York, they had a huge flooding happen. So now what they're doing is along the promenades on the sea, they create a nice public realm where you can have the jogging tracks, all this, and then they create a nice mound so that the mound acts as a barrier so that the flood water doesn't enter into the city. So we have to look into the natural barriers, also try to see elevating the buildings on the stilts. When you know that the area is always flood prone, so it doesn't make sense to have the ground floor to be habitable space. It could be raised on the stilts, and when there is no flood, you can use the ground floor. But otherwise, most of the building could be on the upper level. Even recently, like in Hyderabad, we had the situation. Of course, it is due to different reasons. So because we are building within the drainage channels, so that's why these kind of problems comes up. So we have to understand the environment, topography, and how to respect the hydrology.
Okay, thank you, sir. A few more questions related to, since you have brought up that floating city, there are 2 or 3 questions related to that. First question is from Mohammed Zain, second semester. Sir. He asked, what is the future of floating cities in India?
Floating cities in India, we don't have, except among the coastal areas. I don't think we really need to worry about that at this moment, at this point of time. Maybe in Kerala, along some of the areas, you can do resorts. This can be developed.
And the same thing, sir, and in continuation with that, Ananya, his classmate, she asked, Syed, sir, when we talk about floating city, the problem that will mostly taken into consideration maintenance of water. How do you think we can eradicate that?
See, you have to have a fresh water supply for the consumption. So you have to desalination. Again, desalination, we need to look into different aspects. For every 2 liters of water, you get 1 liter of fresh water, 1 liter of desalinated water. So if you're talking about the desalination at a large scale, this will have adverse impact in the marine ecosystem. In fact, Saudi Arabia is one of the largest countries in the world which use desalinated water. The water which we are getting in Riyadh is coming from 400 kilometers from Eastern Province. Can you imagine that? But still here, the people, they don't really respect the water. So coming back to the question, so they had to try to find ways to generate water which is less impacting on the environment.
Okay, thank you, sir. One interesting question is from Shivani, sir. Shivani, second semester. So what kind of materials should be used to reduce the emission of carbon dioxide? Or what are the ways to reduce the amount of carbon dioxide emitted by the buildings?
Yeah, basically there is a carbon footprint. Like suppose you want to use a stone material in your project. If you want to bring it from Italian stone, from Italy, so that will have an embodied carbon, because you are not only talking about the stone, it has to be transported. So while transporting, you will be spending a lot of fuel or other means. So that's also carbon footprint added to the project. If you source the local material where you don't really go more than 100 meters, 200 meters, so you have to see how best you can use the local material to reduce the carbon footprint. Similarly for all the materials. So this is very important to be sustainable, because you don't really, unfortunately, one of the projects which we did is Indian Embassy in Riyadh. When I was in Delhi, I worked on this project with Virendra Khanna Architects. When I came to Riyadh, it was under construction. And all the stone cladding, Dholpur stone, red sandstone is imported from Delhi to Riyadh.
Riyadh, okay.
Yeah, so this adds a huge carbon footprint, which is not required. It could have been done with the local material. So this is like one of the examples where we can say we can reduce the carbon footprint for them.
So a few more questions, sir?
Yes, go ahead.
Okay, yeah. This is from the Dean.
Yes, please.
He has asked about the interlace project, sir. What about the building bylaws part while designing the interlace project? When we actually twisted them from vertical to horizontal, I suppose that's.
Yeah, building bylaws, basically what happens is they have the height limits and the ground coverage. So as long as they are within the height limits, because all the towers which are vertical, now they put it horizontal way. So maximum number of floors is 24 floors. So that is within the limits. So keeping all the building bylaws, they could achieve much more than what could have been done with a regular stack of towers placing all around the site. So even in the Indian context, we should be more proactive and innovative to see how best we can utilize the bylaws or even the standards and come up with something new. This is what all innovation is about. So that's why I like this project Interlace, that the way it has been done is quite interesting.
Beautiful.
Thank you, Syed.
Sir, second year student, no, it's the first year student only actually. Is it possible to have green buildings in desert, and will these buildings be sustainable in all aspects? This is from Parthiv, sir. First year.
Yeah, let's make it very clear. The green building doesn't mean that it has to be green. It is the word which is given to that. Like if you are go to Rajasthan. So most of the buildings, the mud houses, everything is built. Even Revati Kamat, they were used a lot of the projects. These are all the local materials with thick walls and oriented in such a way that they give enough insulation from the hot weather, and there's also ventilation. So this itself is a green building. It is using local material, local technology, local craftsmanship, and meeting the local cultural needs. So the vegetation, you use the local species. So you don't introduce anything new from outside. So this is a green building. So I think that answers.
Parthiv, I think this is answer. So there's another interesting question, sir, from the second year student, Yashwant Verma. In fact, this is for all of us, maybe. Sir, is there a possibility of turning all the non-green buildings to green?
Sorry, Terry? I didn't get you. Can you repeat that?
Is there a possibility of turning all the non-green buildings into green buildings?
Yes, that is one of the major activities is ongoing. If you see most of the old buildings, you can easily turn into green buildings. How you can do that? Try to see what are the areas where the fenestration, can we redesign the fenestration? Can we create a more energy efficient lighting? Can we conserve water by trapping stormwater? So all these techniques can be utilized. So we can do that. That is one of the, there are a lot of consultants working in this area where they convert the existing buildings into green buildings. This is possible. This is to be done, in fact.
Okay. One philosophy question from Sriman sir, from second year. He asked, is architecture, I mean, according to you, is architecture innovation or discovery?
Discovery and innovation are two different things. Discovery is something which is already there. You go and find it. That is a discovery. Like Columbus went to certain land and he found that there's a land there available in the country. But innovation is not like that. Innovation is use the material what you have and bring more from within that. So doing in a more innovative way by using less material or less, like the example of Gensler Tower. They have a tower, the surface area is still the same, but by rotating the building in such a way, they reduce the impact of the wind. By doing the wind tunnel testing, they know what are the areas, what is more efficient we have. So that way they try to optimize the amount of glass required and the structural bracing required. So that way you reduce the total structural strength, which is not required to be heavy strength. So that way they optimize on the structural system. They saved a huge percentage of it. So this is innovation. This is not a discovery.
Discovery.
Yeah, that's the difference.
So this is a question from faculty, sir, Faculty of Architecture, Shiv Kumar. He asks, sir, is biophilic architecture in trending to heal the environment apart from sustainable architecture? How impactful is it on the environment?
Biophilic, basically, you are trying to mimic the biophilia, the plants, the general natural life. So again, this is part of the sustainable principle, how best you can utilize the plant material and the views and all those things. So this is still part of the, it could be part of the green architecture.
There's another question from Shreya, sir, second year. Sir, what technologies dominate in green buildings? The technologies.
Technology, again, like I said, it is a passive as well as active. We have to see what kind of building we are generating. Like one example which I talked about is the Rajasthan, the mud buildings. So that is also one technology. But if you want to go with a larger scale where you have to have a big building with a big footprint, so probably you have limitations in terms of the mud buildings. So you have to adopt the composite structures. It could be infill with the mud blocks, it could be concrete structure. So it has to be specific to each project. Project needs, we have to develop the technology. Like for a high-rise tower, it has to be different. It could be steel structures. If it is a horizontal spread, it's a different kind of structures. If it's a subterranean structures. So the technology is depending on the project needs, how we are going to really address the functional requirements as well as aesthetic requirements and the environmental requirements. So there is no one solution that this is the solution for.
Fine, sir. Another one question, Ar.Syed from second year asks, I mean, according to you, is Gaganyamism in Bilbao by Frank Gehry, is it a great design? I mean, he agrees that it's a great design, but he also says that it has got no natural ventilation.
Yeah, sorry, some of the buildings which has been done earlier, before we really talking about sustainability, they really went for the looks, aesthetic looks and whatever the concepts. But if it's not meeting the sustainable requirements, then to me it is not a good example of an architecture. So I'm sorry to say that those things I don't really support.
That's fine, sir. These are our views. So I think it's perfectly fine.
Yeah.
And Varshit from second year asks, does vernacular architecture help in carbon neutral?
Yes, absolutely. Yeah. Because you are using the local materials and local techniques and you're using the local craftsmen. So that way it helps the footprint. Sometimes you can really make a zero energy buildings also. You can generate energy. So vernacular is what we should always develop and you can improve upon that.
I really didn't get this question. The one is from Karthik Patel. He asked, what is the effect of aerodynamic in the architecture?
Yeah, aerodynamics is like, again, I can talk about the Gensler Tower. The way it has been designed is they have wind tunnel testing will be done mostly for, so how the winds are moving. When the towers are there, sometimes the wind force is so strong that you cannot really walk close to the buildings. So the aerodynamic studies have to be done when you're shaping the buildings and the surroundings, so that the flow of the wind is not too gusty and the building will not have high structural requirements to resist the gust. So this is very much required. Like when you design the cars and aircrafts, yeah, aerodynamics is part of the studies. Similarly, some of the buildings, when you are doing that, it has to be taken care. Even the Apple building of the Foster's, if you see that the fins, they are like a short shape, so that the wind doesn't really stop that, but it will flow into the cavity to enter into the ventilation system.
We have one question from second semester student, sir. I mean, she'll know about this in the future, but still I'm putting it across since she has put in. She is asking what's the design process in landscape architecture from Vijay Lakshmi, second semester.
Yeah, landscape.
Shortly.
So first you need to understand the site, how it is sloping. It's sloping north side, south side, how the water is getting collected. So you have to understand all the natural forces within there. The slope, the type of soil, is it a rocky soil and rocks are there? What are the features within the site? How to preserve them? So that you have less impact on the site when you're developing a building. So site analysis is very important. The sun orientation, I think this should be part of the curriculum, which is very much to be taught. The site planning process is very important. So that helps you to orient the building in the right way, and so that if it's a large site, how to take care of the hydrological conditions, especially when it's flooding. So all these aspects need to be looked into
that. Thank you, sir. I think this is the number of questions we have received so far. Yeah. Thank you very much, sir, for your patience in answering the questions posed by students. I think that, thanks a lot, sir. It was very enriching. This was very enriching. Over to you, Prasanna. I think you can take over.
Yes, sir. Yeah. Thank you so much, sir. Thank you for your inputs on innovations in architecture and for your valuable time. We hope the students got a broad picture on sustainability and views on future innovations in architecture. And on that note, I would like to call Professor Ajay Sinha sir to introduce our second speaker of the day, architect B.T.Srinivasarao. Over to you, Ajay sir.
Yeah. Thank you, Krishna. Thank you, sir, once again. So, welcome, B.T. Srinivasarao, sir. I can't see him in the picture, but I've been constantly hearing about you. I've been constantly reading about you. I am part of the alumni, so I get to see your messages. And it's always a pleasure to keep reading the kind of messages you put in, or it keeps us thinking, keeps us to get to think and all. Thanks for all that, sir. And it's an honor for me to actually introduce you to these people. And I hope we continue this relationship in the future too, sir. I shot this thing. I mean, his profile is also so beautifully done. I mean, it's just like a story written, and it's a summary written. It's so beautiful. So I'll just read out from that. I don't need to actually add anything or this thing. So I'm calling him BT. So BT comes from a small village, Kaur, in Andhra Pradesh, and selected architecture without knowing what he was getting into. Okay, and from 1988, I think we are from JNTU, Hyderabad, India. His other choice was BTech in agriculture. The other choice was BTech in agriculture, and during the 5 years at Hyderabad, he developed keen interest in history of architecture. Thank you, sir. I think I got a lot to learn from you. I try and teach them some history some now and then. So I hope I'll get to learn a lot from you. And he took the opportunity to join the class at SPA Delhi in the newly set up conservation department in Delhi. And in 1990, he completed his MR from School of Planning and Architecture, New Delhi. And his thesis work dealt with studies of old Hyderabad city and proposals for Mahbub Chowk area, which is recently restored. Those who have been in Hyderabad, I think, are sure know about this Mahbub Chowk area. And after his post-graduation, BT was offered to join the department as a research associate. And during this time, he had worked on heritage development of Amber, Jaipur, Delhi, and Connaught Place in Delhi. And in 1993, he received scholarship to continue heritage studies at University of York. And he has completed his MA from Advanced Architecture Studies, University of York, England. And soon after returning to Hyderabad, he briefly taught at JNFU and then moved to Kuwait. I can go on. During his career of a span of 27 years, BT started his career as heritage architect to restore the complex of palace buildings in Kuwait after the Gulf War. And he then continued build heritage department to list, document, and restore and reuse historic buildings of Kuwait under National Council, which is similar to National Trust here. And after successful restoration to the palace project, Kuwait in National Council invited BT to start Heritage Wing to advise and lead documentation of historic buildings. So that's really awesome. And he developed Heritage Division with vision and strategy planning and management that oversaw several pilot projects for reuse during his tenure, including Dixon House, Ar.Syed, Sadhu House, Qibla House, Old Museum, and City Gates. And this gets interesting, like he was among the first faculty group to set up Kuwait University's architecture department. Sridhar, we know him. Sridhar from T1 and Bashir joined the faculty as well. And introduced teaching traditional architecture of the region and supervised students to work and focus on infill development and designing for context. Many of the students are carrying the torch in researching and restoring Kuwait's heritage. They're still doing that. And BT continued his work with Peter Lowell, who is the top consultant for heritage work in Melbourne for 2 years. And from there moved on to design management with Collins Towers at Melbourne and then to Turner International. And since 2008, he's the senior design manager for Turner International Middle East region. And during his time, he's dealt with projects ranging from designing small villa extensions to palatial buildings to urban level project, currently managing the design of academic medical campus that includes A to Z of medical teaching, research and practice. His current discussion is from the work he did at Kuwait University in developing the course and his papers regarding restoration work. He believes that heritage is inheritance, creating values that is beyond invaluable. He strives to bring out value in design that is easy to realize and maintain. In deciphering architecture history to set the design principles and styles, practical and simplified solutions help usable spaces that create a place. In design standardization, options for value engineering, and to look for construction and beyond to usability and future proofing of buildings. So currently, sir, BT is the senior design manager with Turner International for the new Kuwait University. And he has been doing land development for 50,000 students, faculty and staff, estimated at 10 billion, costing about 100 build structures. And I'm sure I can still go on, sir, but it was so interesting. I had to read all out. I mean, we were supposed to edit out some parts, but the resume was so interesting. I had to read it out to the students. I mean, I found it very interesting. And please take over, sir. Please take over and please enlighten us more on this.
Thank you so much, Ajay, for the long introduction. It's for me, architecture has been a search all through and still is. And I would like to first of all welcome all the students that are joining this conference. It's great to have you because you are entering into an era that really brings upon what you want to do in future and what you would be shaping our cities and towns and buildings. And definitely, as Syed said, who is my friend, the environment in total. So we start with a small thing like a house design, which would have a big impact if thousands and millions of houses are being designed in the same way with one objective: to protect and save the climate and protect ourselves from the climate, and then minimize the resources, etc. So this is a great opportunity for all the students to look at architecture in terms of a very new era that's actually started a few years ago and then really now being pushed on with the climate change movement. I really thank Syed who has brought up this topic and very effectively, innovatively judged the concepts of climate change with the modern, very innovative methods that architects are working on. And I'm sure the faculty, who is very able, very interesting. I hear from Professor Ramakrishna about the new things that the faculty are innovating into teaching methods and bringing on. I mean, when you talk about BIG or Foster's, I'm sure you're already putting in the upfront architectural development that's happening. At the same time, I also look at visionaries like Professor Dr. Rodriguez, who's already talked about how architecture has to shape teaching and buildings. When you works in university, he's talked about how the building itself creates an interesting environment for teaching. That's very important. We spend our lives indoors most of the time, and how we shape our lives depends on how the buildings shape us. So architecture is really intertwined with what we do and how do we live. To this conference, I would like to present very simple things that what other architects have been doing. And again, most importantly, about what the architecture contribute to climate change. Thank you very much for having me here. I would really be very visual because I see that the students, I'm sure, would be going into the technical aspects, but I would like to impress upon them that whatever is happening in terms of architecture on the West is one direction. That is, everybody is trying to save energy. Everybody is trying to use less number of resources. Everybody is trying to put together a sustainable architecture. So how successful one is in terms of what they did is the result that the building comes through. So somebody will be very successful, but everybody is trying to attempt to do that. That's most important from what I learned from about 30 years ago to now, because when we studied architecture, climatology was just one subject, which was engrossed upon, and it's treated as an engineering subject more than an architecture subject. But architecture really is about engineering the environment to design your building. So how do you design your building in terms of enveloping yourself to protect yourself from outside forces, outside climate, which is most of the times harsh and not comfortable. So you are creating a comfort and enveloping yourself into designing something that protects you. That's where I believe architecture is really, whatever you do, the architecture would be effectively shaping you or what you do in future. So with that, I would start a PowerPoint presentation to share my screen. Can you see the screen now?
No, sir, not visible now.
Okay.
Now it is.
Okay. So in broad, the general topic that the school has introduced and directed us to do, the construction marvels and novel architectural innovations of recent times or recent years, is really about what we see, what we call novel, or somebody asked the question, is architecture a discovery or innovation? Is really about what you see the building and how you see it and why you want to remember that building or what it taught you or what communicated to you. So when you look at a building and it impresses that, that's a great building, and I know it turns your head and says, oh, that's something that is different than other buildings that I have already seen passed by on the street, is really how successful an architect has been. In terms of, because it creates a visual impact on the students or the visitors, the people on the street. So for a common man, when he turns his head and looks at the building twice, that means he's impressed by its looks. So the looks are basically the building's frontage, the facade. The word facade is coming from a Latin term, fascia, or French term, facade, which means basically the face. Your face is your identity. And how do you appear? How do you, express yourself through your face is the most important thing people remember and identify yourself. It's exactly the same way how architecture is identifying its building. If you look at a building and you remember it and you identify it, is because of its facade. How the whole envelope or how the four corners of the building or the four sides of the building is appearing to one person to other. So that's very important to build a memory of an architecture that you are creating. It's a memory that you embed it into your brain because you're creating something that's different, that's innovative, that's creative. And we'll talk about the other aspects later, but that's the first impression architecture creates. Whether somebody asked the question whether Bilbao Museum is a good architecture or a bad architecture, but definitely we're talking about this because somebody created that vision or an architectural form, which we're all talking about, whether it's bad, good, whether it's successful or not, but it has become a topic of discussion because it's a great building. We have to agree on that. And then it's a great building because it's got innovation in it. It's got creativity in it. It's turned your head and asked you to look at it twice, more than twice. So and talk about it. So that's where architects come in to be different than any other professionals who are designing so-called buildings. So you have to be, entrusted. You have to be creative. You have to be separate, and you should put all your innovation and energies to be something that brings onto the ground a creative energy that you are putting onto paper. So in my opinion, that's very important. A face talks to you, and similar way an architecture talks to you. In terms of face, what is a face? A face is somebody's frontage. It's been carved out. It's been painted in several ways from the very beginning of human evolution. This is an artwork, if you remember, it's from Indus Valley. So people prehistoric are also, trying to create an identity of a person or an innovation. Similar way, if you look at Mona Lisa, nobody will forget about that face because it's got that something that's unknown, something that an artist put it effort to create and show you something of a face, which you will not forget. It's the same way that when an architect innovatively creates a building and puts onto the ground, you would want to look at it. And face can be different ways. It's gone through, very prehistoric areas to modernism and postmodernism and technology and digital and nowadays. So, if you look at a series of faces, this is by Picasso. If you know who's innovated the painting and artwork in terms of cubism, or pop art, which has been very famous in 60s and 70s. Again, it's a face, but done in a different way, or very abstract way. For example, Pollock's paintings on the left side, or Le Corbusier's imagination of a face. This is the painting on the right by Le Corbusier. So put together, these are all faces, but each one has its own identity, its own individuality. And in a particular period of time, it's the most famous face that is painted by an artist, an architect. In the similar way, how architects put together the buildings on the ground, you would be remembering the facades. So these are, for the students who probably are just joining, this is a famous architect, Zaha Hadid's face, and how people imagined her in different ways. So some of the artists put together her with her, because she's called the queen of the curve. So curves are her very essential architectural element, and that's how she's portrayed. She's been also portrayed as a very aggressive and arrogant sometimes. So the other one portrays her that way. But so architects' innovation, architects' creativity, thought process, all is embedded into what a particular person or architect creates onto the ground. So I've already mentioned the facades talk to you, just like a face expresses to you. The frontage has a meaning to it, and what you wear on the front, whether it's makeup or without makeup, or it's just your hair or your expression of your mouth, eyes, is all visual. So the similar way architecture does the same thing. It tries to speak to you, communicates to you, and expresses in a way that none of the other art forms expresses. All the other art forms like art, painting work, a sculpture is just there to look at. But architecture, you actually can walk in and live that art form. In the sense of envelope, or when what we are trying to do is creating something around yourself to, for example, if you're building a house, you're trying to live in the house to take rest, to read, to study, and do your daily things, but you're trying to envelope yourself around you with 4 walls and a roof and a floor. So all that we are trying to do is create these essentially 6 sides of an envelope. So the major part of this are 4 walls, which are called facades. Of course, you have front facade, rear facade, sides, and sometimes facade come roof, which has been very innovatively done. All of these are elements that are separating you from the outside climate. Just like what separates from inner body to the outside body by a skin. So that's why the topic I chose is today called double skin. A skin, again, just like a human anatomy, everything is being tight, protected, and formed into and covered by a skin, and then it has particular functions, as this diagram shows. A skin is mainly protecting from anything that's trying to enter into your body from outside, which is causing damage to it. And also skin is trying to breathe and protect, and then take out the bad part of the body is from through the sweat. And skin is trying to protect from the heat, dust, climate. And skin is trying to repair itself. It's absorbing. It's at the same time it's giving away. So all the functions that the skin does, exactly the same the architectural facade does. The buildings all around, the 4 sides does the same thing. The roof does the same thing. The floor sometimes does the same thing. So a skin in terms of doing architecture and then creating the architectural skin is probably the most important aspects of whatever you do in architecture. So just like a skin, architecture also protects, the facade protects you from environment and provides you a shelter, provides you shade. More importantly, it provides you safety. Once you go into a shaded environment, you're protected, you feel protected, and you have a private space, then a public space. And of course, it provides you security because you can now enclose and close yourself into a house or a building. So it is protecting from any untoward elements that are coming onto outside. So all these functions are exactly the same as the skin does in architecture. But what is trying to do damage to architecture? If you why don't we just open the buildings out and then live in it? We can't, because rain, I mean, we have, of course, we live in a natural environment globally. So you have, first of all, the climate conditions where heat and rain, dust, cold, all these are elements that are trying to get into and damage the materials that are there. So you have to be creating something that, of a skin that keeps all these away from it. In cold climates, people would like to heat their buildings. So they have to protect from them, from the very cold climates. In the hot climates, they have to protect from heat, like the Middle East. In the same way, in a very temperate climates and rainy season, people have to protect themselves from the continuous rain that happens. And so by separating one from, protecting one from outside to inside, and architecture be giving this is done in many different ways. How you treat your facade, how you treat a particular phase of an architecture is also giving it an identity, because you want to create a person's identity by its face. And also in the same manner, it overlaid by expressing what the building wants to say. Does the building want to say it's a museum, or the building wants to say it's a house, or it's a courthouse, an office building, or something else? So it has an expression built into architecture. And architecture cannot be, when we had an opportunity to speak to Foster a long time ago, and those days there was a conversation about what he does to his buildings. So he treats all the buildings in a way most effectively by saving energy and using the purity of structural work. So there was a question which says, can I drink the wine from a teacup and tea from a wine glass? So both are serving the same purpose, because when you drink from a teacup, it's trying to put the liquid in it, takes that shape, and then you're trying to drink that. Why not a wine glass be used? So, but both have a different form, and one form expresses in a way it is meant, and it's built into our thought process that's meant for drinking a particular liquid, rather than other one which has a different set of form and shape and material. So it is in the same way the question is answered that for him it doesn't matter as long as it serves the purpose and it has served the budget and resources. But most of the architects would try to express that as the teacup is a teacup and not a glass. So the most innovative architects and most expressive architects also would use their creativity to actually bring it out onto the facades. Buildings have been designed, of course, with with skins all around, with facades all around, and we remember them by those facades. But today's topic I would like to touch upon, we have what we call double skins. We are not just been now protected by one layer of facade around it, which most of the times, till recently, when the technology has not been so evolved, up to 60s, we have concrete, brickwork, blockworks, stone, all these massive masonry walls that are shaping our buildings. So just like this picture, you have a very thick walls that are structurally supportive and creating that envelope. Now, slowly, with the involvement of concrete and steel architecture, we have now been able to support large and tall buildings without actually using the massive, very heavy masonry walls and only use them lightweight as much as possible to serve the same purpose. So that allowed us to move on from creating a massive envelope to a lighter envelope and probably to 2-3 envelopes more than one. So these buildings are quite traditional, normal, brickwork, block work, stone. But the facade technology, when it started evolving, you started looking at what are the options that we have. Options in technology of materials. We have a different materials altogether. The range of materials are quite different to what we have in 1960s or 70s. And from 80s, 90s onwards, when the technology started improving in terms of architectural materials and the way that technology could use, glass, aluminum, plastics, FRPs, GRPs. FRP is fiber reinforced concrete, glass reinforced concrete, and still going on. All these materials are innovative and supportive on selecting the facades differently. Like the Bilbao Museum, for example, it's got a skin that's completely never been used. So architects basically depend on the new technology that's coming and which is trying to basically say, provide all these functions on the screen, trying to save you from the UV rays, trying to cool or heat the building, and trying to save the energy, trying to insulate from next door by acoustics, and taking the daylight or cutting off the glare and ventilating naturally. And this can be done in many, many ways, because when you separate the skin from the main masonry or a main, what we call rain screen of the building, then you started to evolve into architecture that's multi-layered. You're no more having a building that has just 4 facades. You have basic 4 corners, 4 envelopes, but you started exploring the front or wherever, or the roof even, into multi-layers. The multi-layers will become attractive to basically do a few things. Most importantly is the heat. You're trying to protect from the heat or generate heat. So in colder climate, they're trying to generate heat to the buildings. In the hot climate, they're trying to protect from the heat for the interior. So for example, if we take the Middle East, the outside temperatures go up to 50 degrees under the shade. 50 degrees centigrade under the shade is not a comfortable temperature to just go out. But you want the temperature to be inside to be about 21, 22 degrees, which is a comfortable temperature to work, live, or play. So that 30 degrees of separation is created by having innovative materials like triple glazing these days, or creating multi-layered shading in front of that facade, so that it is first of all protecting. It's trying to transition from 50 degrees to 20, 25 degrees. So that's very important. By doing these multi-layered facades, you are trying to create major energy transfer into the buildings by this. It is not just energy transfer or saving the inner climate to outer climate. It is now becoming it's an energy saver, because the more you save energy by not allowing the heat to come inside, or not allowing the cold to be heated by generators or heaters, and the facade is purposefully doing that function. I mean, it's generating the heat or cold by itself, cooling the building by itself. It is actually saving energy, because most of the energy in the building is consumed by the comfort that we are trying to achieve with the mechanical means, that is cooling or heating the building interiors. So if you go to these days any of the malls, the entire mall is air conditioned. So that means at the back of the mall, you would see so many generators working and so many air handling units working, pumping cold air into the project. So all that is causing you either natural resource, that is generators being run by diesel, all the energy that is coming from coal plants probably. So all this is energy consumption. So what we are trying to do is save that energy by blocking the heat to come inside. So instead of 50 degrees centigrade outside, if you block it by any means, the next layer will be about 10 degrees maybe it's 40, 30 degrees, then the layer of your envelope would further provide you to protect maybe another 5-6 degrees. So your cooling of the building will be reduced quite a bit. It's not only that, the building facades are now becoming actually energy producers. We started off doing this double skin or multi-layered facades to save energy, but actually instead, in the recent innovation of photovoltaic cells, which probably many students now are aware, you can generate power from the solar panels, solar cells, photovoltaic cells that you have in many innovative ways being used for household, is being transmitted into the building facades. So the building facades actually are generating energy, generating electricity, and being used within the building. So you are neutralizing whatever energy that you would like to use for the building is being generated from whatever is the shape the building is outside. So I'll quickly go through some visuals and see how buildings are being attempted to see. These are multi-layers of facades. This is a building by NBBJ, College of Science. Most of these are institutional buildings that I worked on, which have several layers of built-in aluminum or fenestrations facades. Aluminum is a great material that's done appropriately. It provides you a cut-off glare, cut-off energy or heat from directly transmitting into it. So the way that buildings are done, for example, this one is innovatively done by creating a diamond-shaped shading, and which is stuck by a structural means to outside skin. So what it does is a couple of things. One, it doesn't allow the sun to directly come in. So the 50 degrees temperature is being protected and it's shading the glass behind it. But at the same time, it allows the bottom, if you see the fountain below, it's trying to cool the air below. So that cool air is being passed on between the skin and the facade. So trying to revolve the air around the building so that it creates an inner courtyard kind of arrangement within the skin. So on the right, you could see how the facade has been jointed. Here, it's a very standard approach where the louvers, which Le Corbusier used many ways in concrete, but here it's a skin that is attached to the major glass wall or the curtain wall behind it. The vertical louvers provide the shading from both west, which is a very hot sun in Kuwait, to allow shading into the building. Sometimes the roof itself is when we have to bring in natural light, the roof has openings, roof lights. The roof lights have now been provided with solar panels as well as withdrawable shading devices. It could be fabric, it could be something like this, which can be drawn back and then opened up when the climate is better, or closed off when the climate is too hot. And the other aspects of using GRP, for example, glass reinforced concrete, is this way, where the architects used innovatively to envelop their buildings into a complete facade where openings are kept only to minimal. Anyway, these are examples from the very hot climate, but you could do the other way by allowing the light to come in, but and produce heat onto the glazing by allowing that, so that your cooling load heating load is reduced in colder climate. Here, the same thing. Originally, the architect's intention was to put glazing, a completely glass facade, then turned into a fiber glass facade, which is protecting it from outside. So this is the in-between space where there is a glazing and the actual facade. Most of the times, this is not very new to actually what Middle East does, because the Middle East, the climate has always been a problem, and then architects found different solutions. There is a word called misrabia, where it's like a jali work, what we call jali work in India. Many of the balconies have a jali in the front, and it allows you to go there and get cool air, because it's got smaller openings. When the wind hits, the hot wind hits it, it's got reflected, and then when you are sitting inside the balcony with that kind of, you feel cool air coming in, because your hot air is transmitted into a cool air. And this sort of does the same thing. This is they create an aluminum kind of jolly work around the building, and with the wind flow, trying to cool the facade, which is inside this jolly work. This is where that is the space between the jali or the mushrabia and the actual facade inside. Another interesting building by SOM architects, where they have coined this as a form. Shades of Knowledge is the name of the building in Arabic. So this created completely a building within a building. So they have enveloped the entire, actually this is a library building, entire library with another shaded building. So the outside aluminum panels wherein there are graphics. In fact, it is designed by artists themselves to look at Islamic architectural patterns and how they can transform into creating something modernistic and innovative. So the patterns are done and then put onto the panels, which provide you various different shade. When the building is in the during the daytime, if you go into there, all the white walls are splashed with rays of light and the shades of these aluminum panels, which were very, very innovatively used. This has been used, by the way, similar way by G. Novell with Abu Dhabi Museum. And sometimes the shade is provided by the fabric, and the fabric shades are plenty used in Middle East. And the roof, of course, is another way to do it. Roof and the facade sometimes are bound together, and then it sort of creates a shade, first of all, because sun is most of the time vertically placed. So once you protect the roof and then draw shade onto the roof, you are actually saving a lot of energy that is going into the building from the top. An architect tries to do, this is a sketch for one of the architecture college buildings, what we are designing. So we first put together the function and then function program of the building and shape what could come into the site with the site analysis. Then we started looking at options of how to protect the interior from the very harsh Western solar heat that is going to be hitting that facade. So, this building is now being drawn as a sail. What you see is an architect sketch drawing these, multi-layered facade on the top to be like sails that will protect the building from inside. Somewhat like this. These are famous architects. I mean, this is Alibaba headquarters from Hong Kong by Hassel, very famous architect, again, doing a similar work. Look at the facade differences, because the one that we are facing is got a lot more openings than the one that is on the side, because that is an elevation that's on the east. So they would like to have the eastern light. Eastern light doesn't have too much heat, so that is allowed inside, whereas the western light is being blocked. In terms of when we do that, the architecture, the skin requires to be really integrated into the building facade behind. That is done by structural means, whether the structure is linking from the slabs or from the roof or the floor. So it has to be dealt with. So always there is a structural integration that has to be collaboratively done. And it is also drawn into the interiors. When you design these skins, the light that penetrates into it creates lots of these sort of mural kind of atmospheres inside. This is an example of how the skin is being supported onto the wall behind and provides you these ladder and lid spaces for maintenance or anything that is behind those skins. There are many ways for innovative ways for doing that. It's a very similar example I talked to you about, how the glazed wall is being etched so that in the night it appears in a different way than the day. The facades now are dynamic. They change with the climate, they change with the sun, they change with the dust and wind. Many architects have worked on it, and these are dynamic second facades that produces energy and then sometimes advertise themselves as buildings by light. So it's basically how you sell your building, how you, particularly for those commercial corporate buildings, the facade is an element that sells their product, their building themselves. But there are ways also that are coming into picture, which are green buildings or green clad buildings, wherein the second facade takes on and puts on a facade of greenery, complete greenery in the front. Can we call that green skin? That's being coming in. It's very, very well done in some of the European architects have done it very well. And solar energy and the efficiency of PV panels is being going on and improving. The effectiveness of gathering energy is being improving, and then these facades are becoming more and more popular, so that facades not just only protect and save energy, but actually produce energy. Similar example where the solar panels are clad on the facades randomly, but this is actually bringing in the energy to the building. Facade, as soon as facade, we say that facade. I'm sure the next speaker will talk a lot about the innovations in terms of structural work, how difficult process it is to actually build a facade. This is an example that we looking at trying and testing the facade and whether it's working in terms of solar gain, heat gain or heat loss, as well as how structurally stable, how lightweight it is so that we can save the structure. So there are a lot of things that come through when you look at facade engineering. And comes, of course, everything comes with a cost. As soon as you say a second skin, oh, how much it will cost? Because you're not just putting a skin, you're applying makeup to it, or you're applying something else to it. So there is always a cost component when you design a double skin facade. But you have to prove to the client, or you have to prove to yourself, first of all, what does the second facade provide you with? Because as soon as you say, it is saving me an energy in terms of dollars, in terms of per year maintenance, of providing energy and innovating, there is an offset which clearly identifies your saving in cost. This is a very famous building I'd like to show at the end of the presentation, but this is a CH2 building in Melbourne, which is done by Design Incorporation, wherein you can see the facade moves. These are very simple, louvers by wood, and they mechanically move whenever the weather is day or night. And of course, the roof lights have been quite popular. Most of these roofs now have solar panels, and the facades are protected from there. Sometimes the buildings actually shy away from addressing people because they are meant to be, because as things like data centers, things like security buildings want to be hidden, on maintenance buildings, very large equipment want to be hidden, and the facades provide for that. It's like completely a blocked facades, wherein the landscape comes in upfront and then takes away that expression. So you are looking at a building behind landscapes. And facades come with, of course, whatever locally available materials. Architect Sai talked about, how important to look at what is locally available, rather than, why not import Italian marble or Italian louvers or American solar panels, etc. Because you need to look at what's really next door to you. You should go to the next door shop and look at what kind of materials that we really have, rather than dreaming of something that's not available. Because there itself, you are faltering, you're trying to create a loss of energy and cost. So for Kuwait, particularly, we have a lot of good, precast panel manufacturers. It's a cheap way to clad your buildings or create a second skin. And these are some of the examples. And here you can see that the skin has been applied in various different materials. So when you start looking at options for your facades, you have several options depending again on what you want to do with the interior. Whether you want to shade the interiors, which is right here, what you see is internal shading by drawn louvers, drawn curtains. So there becomes a second skin, which is inside the building. Or here, the skin is itself a program. The skin program is a corridor, and onto the right side is actually the building function. So the corridor with a skin separates the building by creating an internal environment for collaborative space for this is a college building. So the function of the skin is now doubled by having it as a circulation space. The skin also looks at how the landscape is playing its part. For example, the traditional buildings originally were done, you have to wrap around and deep set windows so that you're protected from climate. In here, what you see that you can look at the windows, how deep they are set, almost like 1.2 meters, because that's the sun angle, an angle of incidence. So you want to protect that. So the masonry is really drawn back. So it takes away space, and the double skin gives you that advantage of, giving that space somewhat of an use. Sometimes the facades speak because now creating with the digital environment, and also if you look at what's happening in the industry of visual graphics, there's a lot of facades which are playful and graphics introduced. This is a mural by an artist in Stanford. It changes every minute. So the mural recreates by itself by people who are passing by. And when you do it onto the roof, when you do the multi-layered roof, you start looking at many options to create your building facades within that space, because you already shaded the building. Now you can start to look at maybe opening up into the glazing and then visually connecting outside to inside. So that when you do that, then you have the option of putting in a lot more materials that are natural and then varying. The internal double skin, for example, this one, the glazing, which is called a fritted glass. Fritted means it's got spaced out etched casting in ceramic, so that it sort of provides you some sort of a translucency to the outside, but at the same time protects the inside. Or the precast, and a varied degree of precast panels. These days, we are also looking at innovations of gathering energy by interior lighting. This is an example, again in Stanford, where student desks of research student desks are covered with a solar panel, which is kept inside. So it gathers light and turns into the solar and energy that is powering their laptops. So the innovation is coming soon. So interior walls, interior facades are going to also start looking energy savers and energy gatherers. Facades that communicate, this is another digital graphics facade where, again, it changes by minute. It actually talks to people. It creates a visual sense of, also creates knowledge. Particularly in terms of institutions, when people are passing by and sort of teaches you something new, something different, it's always good to interact. The facade starts interacting with you in here. This is a similar picture that I have shown earlier. This is the graphics. Internal louvers, we know about curtains that we draw from interior, so that first of all, visual privacy. At the same time, if it is the heat is coming or the light is coming, we draw the curtain. So it's a similar fashion. The louvers are within the glazing to close off. And another example of how the direct sun is being cut off by, first of all, the horizontal shading, and then again, there is a smaller internal louvered shading. So this is really the way that the architecture is, I believe, is going through to save energy, to produce energy, and to create a cohesive and sustainable environment, the way that we shape our buildings and live in it. So when we start designing buildings, I believe the most important aspect that students should be looking at is this: how you are trying to save energy, produce energy, how you're creating your innovative facade with these aspects. So those studies are most important. The climate class, I think, is the most important to do this. I just want to end this with a specific design that's very innovatively done in Melbourne. I talked to you about. This one shows how the building is treated just like a human being. It has a mode at every time. For example, it has a summer mode. So the building functions when it is summer in a different way to a winter. So it automatically controls itself, just like a human being. If it is summer, you would wear a t-shirt and go out with shorts. But if it is winter, you have to wear a pullover or a jacket and go out. So it's the same way the building treats itself and functions. So that's so innovatively done. And at the same time, it has a night mode and a day mode. The building's inner workings of mechanical facade services turn around and then allow the light, allow the wind or the air to flow through the entire building, just like what we do on a daily basis. I think that's really something to talk about. This is done by Design Inc. From Melbourne, and a great building. And with that, I think I'd like to conclude my presentation. Thank you very much for this opportunity.
So thank you, sir. It was very enriching. Yes, sir. It was indeed enriching for the students of architecture. Now they'll start to look at the facade in a completely different perspective. I hope they do look at that a completely different perspective. And with the input what you have given, I'm sure they're going to do even more better. I mean, you have said about how architecture should speak, communicate, and express. So that's one point I would definitely agree with, and the students also should need to look at it. And yeah, there's always this question of can I drink from a teacup, or can I drink wine from a teacup, or can I drink tea from a wine cup? So that's always there. And the use of jali work, on what you stress about the jali work, and CS2 building dynamic architecture, which is like which actually moves, moving architecture and all. That's really a great concept which I've explained to the students. And walls that talk, that was totally innovative. I think it takes a lot of innovativeness for that. So you actually are the buildings are talking to you. You're walking by this. The buildings are actually talking to you. And there's some great designs which you have shared with us. Thanks a lot. Thanks for that. And like you mentioned, even to Syed sir, depending on your time and availability, of course, we would like to take on this association, sir, in the future too. Definitely, I think take this association in the future. Are you with that? I mean, the question and answer session can be open, sir. I mean, are you up to a few questions, sir? I mean, I got in a few questions regarding the thing. Starting with again my question first. I mean, the same thing. When you are looking at the cost factor, you have already covered. I mean, you mentioned the cost factor, but what happens? And this is related to the larger buildings. It might work, but what happens in the smaller scale? Do we still look at double skin architecture, even smaller scale buildings of smaller scale? Or yeah, actually, there are many innovative ways that many Indian architects are working with local materials on this double skin facade. You might have heard that walls being built with pots and terracotta or hollow blocks. It's really an innovation in the sense without air conditioning, some buildings are made comfortable by eliminating the heat from outside. The way, and also with the brick jalis, they have there are some architects who are trying to bring in the natural ventilation to the interiors by the same concept of air conditioning, by creating wet pots and then trying to integrate the air into the building. So you're circulating the air around the buildings, creating a smaller microclimate around the building. So the temperature outside may be 35 degrees or 40 degrees, but within that range of the building envelope, it drops down to 25 degrees. So when you enter into the building, you're already about 25 degrees. So there is a lot of innovation that locally can be done, and in a very cost-effective way. Thank you, sir. This is a question from the first basic question, sir. This is from the second year student. Why is it called double skin? Is it only because of the layers, or is there something else to it? Okay. Yeah, the double skin is it's a direct definition, because when we designed the buildings, as I explained to the earlier times, like in up to 70s, we had not got many options of building facade materials. We were basically having
Natural stone, of course, the most important building material that we already all had from the historic times. And then mortar, brickwork. Then came concrete in 1920s to reinforced concrete. So whatever we did, we supported our buildings on the masonry structure. So that is one skin, that's one facade. So what we are trying to do now is separate that thick facade to a thinner facade and then create another layer so that protects that facade. So that's why it is double layer, double facade or double skin.
Thank you, sir. There's a question from Ar.Syed, second year, sir. He's got a couple of questions, in fact. The first one is, sir, is aesthetics of building important than the concept and the functionality of the space?
I think first comes this is my personal opinion, but varying degree of architects do it differently. But function is the most important thing when you're designing. If it doesn't serve the function, what is the purpose of the building that you're doing? So the function, if it doesn't serve the function, there's no point you build it. You're wasting the resource. But at the same time, we talked about Bilbao Museum. Though it is serving a function of a museum and there are no windows, it's all enveloped, completely closed, because it is the function of the building. It's the museum. The museum has to be limited in terms of natural light that should come through. So all depended on artificial lighting and creating an enclosed atmosphere and closed climatic condition for protecting the paintings or the sculptures inside that museum. But at the same time, it serves a more important function, the expression. Because of that museum, you will not believe how much money that city made or still making. So it's a give and take.
Okay, sir. The question continues. I mean, if a building has a great facade but it was planned very badly, then do we still call that a great building, or?
Unless you know the internal function, yes, it is still a great building. There are many great architects' buildings which suffer from this syndrome that you just explained. It's Ashish, right? So it's a great question, because many of the great architects' buildings, when an architect goes back into the building and looks at it, what is this building about? Okay, that's a great facade, greatly admired and written about, but it doesn't function inside. He has leakages, or is kept something very drastically, long circulation areas, wasted areas, not functional. It all comes down to the people who are working there, rather than somebody going looking from outside, because the outsiders never know what's going on inside. That's why when you try to evaluate a building and assess a building as an architect or student, it's important to look at the building from outside, but it's more important to go inside the building and look for yourself whether this architect has done a good job or not from what he has been given. So when you go into the building, for example, I mean, Korea does very well in terms of expressing this. The buildings are evolved from inside out, not from outside in, as many architects do, because they want to sell the buildings, first of all. Unless you sell the buildings, they will not come to you. But at the same time, you have the responsibility selling the building, but fixing it functionally first.
Ar.Syed continues his question, like, how does the facade affect landscape, or vice versa? How does the landscape affect?
Okay. I mean, I've couple of examples. I mean, the facade can be, if it is a very bad facade, the landscape is the most important one that comes to your rescue, because you can hide the building behind the landscape. At the same time, great buildings are integrated with the landscape, so it gives you a framing of buildings. So how you want your buildings to be appearing for the audience or the spectators, by framing with trees or by foliage, and how from the trees that you actually look at the building. So that way, there is a sense when the landscape architect, architect side is a landscape architect, basically, he knows how important it is to bring in the landscape architect at the conceptual stage. So these ideas are integrated together. What happens is, most of the times, is the design is already done, the building is already done, then comes the landscape architect, because they want to minimize his work. So they'll come and they put some plantation around it. And this is just, I would say, aesthetic makeup rather than actually proceeding, integrating landscape with the functionality of the building design.
Oh, sir, thank you. So this is from Ananya Andolu from first year, sorry. She asked, sir, which facade element, according to you, in the history of architecture is more likely to be used in the future, or which is timeless? Okay, definitely not the pyramids. So, which facade can be most likely be used? Which facade element? Facade element. Okay. Which facade element? I would say, I mean, thinking loudly here, but I would say the colonnade and the fascia portico is a great element of a facade, which provides shade, first of all, and circulation for the building. You know, most of our British architecture buildings have a colonnade in the front or on the side. Even our, old houses have what we call patio or, veranda. It's a facade element. And if you look at it, veranda is the function of veranda is interspace between outside to inside. So it provides shading around the building, the frontage, and then it also creates an interconnectivity between public and private space. So the people sit in the veranda and talk to other people. They do a lot of things in the veranda. So the veranda function or the colonnade function, it is the same patio function, I believe, is a very good element and an interesting element for facade. So you got a lot of questions, actually. I think okay. You're listening very promptly, and here goes another one there. So this is from Pranalika. Is it only double skin architecture? Is it only about the facade or even the roof system? And roof system also is it a part of the double skin architecture? Yeah, there are a lot of architects now working on this concept of there is joining between the facade and roof. Unless you are designing a cube building like this, you are merging the facade onto roof by a curve. So facade integrates with the roof. So most of the times what we are trying to do here, and we are trying to hide the equipment which is on the roof, or we don't want to see the roof as a, just a mechanical equipment area. So we actually bring in the facade up on the roof. It not only shades the mechanical equipment, but also provides with, integrated PV cells, bring in the energy. So your facade actually merges onto the roof. Of course, if you have a dome, obviously the facade and dome is integrated. If you have a curved building, it's integrated. And there are many innovative methods that transcend from a vertical facade, vertical plane to a horizontal plane. How you do that is your creativity. So this is one technical question from the faculty there, Professor Kumar. He asked, how to make the serviceable lifespan of a facade remain same as that of the structure? For most of the facade material available in India has expected a serviceable life of only 5 to 10 years. Not really. I do not agree with 5 to 10 years because India is got a lot of companies that are innovating in facade louvers in aluminum with other materials as well. But I'm focusing on this because these are very efficient, cost-effective louvering materials that are being produced by many aluminum companies, which basically is a vertical facade with small horizontal louvers, and you stick onto a facade. And these are lasting for at least 20 years, I believe. And the kind of maintenance they need is nothing. It's just, if you are washing the building facade, it becomes new, almost new. It just washes off the dust. They are lightweight, so you have no structural, additional innovation to be done to structure. No additional cost. You are just expanding your front to another layer and providing you a shading device in front. So I'd like to know what materials he's referring to this lifespan of 5 to 10 years, because what we are doing in architecture is architecture has to be built for a particular period. I mean, no architecture is going to stand to endless time. I mean, of course, we are trying to save pyramids or Taj Mahal or monuments that are historically very important. But at what cost is obviously the question. So if you have to save a building for next 50 years or 100 years, you would have to input
that investment right away. So the first thing that a structural engineer or an architect goes into asking is how long this building has to be standing is usually 50 years. And beyond that is a bonus. Because in 50 years, your building material technology and your way of making the buildings comfortable is going to definitely change. A building has to allow that change to come in.
Thank you, sir. Pranalika has, she asked you two questions, sir. One, what are the main characteristics of double skin facade? That's one. And continuing to that, I mean, according to you, which material is better, recycled material or natural material to be used in the for double skin facades?
Okay, I think what does the facade do is aesthetics is more important in terms of when you put a skin, but it should not be obvious. It is like how much makeup you put on your face. It really goes to that. If you have very bad makeup and put on all kinds of colors, obviously it's not attractive. It may be saving you from sun because you applied a sun lotion on it, but it is doing the same function. So when you do a double skin facade, it should be doing the function. So it is more of an engineering calculation. So how much shading and how much coefficient you are able to meet and how much comfort you are able to bring in with the limited cost. But at the same time, the facade should not be just a block of louvers, because that way you are bringing more of engineering than an architectural innovation into it. So it's very, very important to get that balance right. The second question about obviously, I mean, you don't want to use too much of a natural resource. We are trying to use as much as possible the recycled materials. I mean, in terms of recycled materials, I mean, the LEED system goes very deep into it. You can look at the local, sustainability codes, wherein each material, a material is made from several processes, and how much this process has, expended energy, or created a carbon footprint is already into the calculation. So you would know if a recycled material has really been energy efficient or not by those technical studies. Going to the natural materials. See, for example, if you would like to bring in marble, right? Marble is you cannot have even though it's artificial marbles are available, artificial stones are available, but people would crave for marble to come from Rajasthan, crave for things to be imported from some quarry, which we are really depleting that natural resource. As long as we get stuff from our earth and the air, we are basically depleting that resource. It can't be replaced.
Thank you, sir. Shreya from first year, so second semester, she asked, sir, what is your thought process when designing a facade?
First of all, I would not design a facade before I mean, my thought process will be starting from a function from the site, whether all the functions that I want to fit are fit within that site, whether it's what should go on a ground level versus an upper level versus a top level. So my thinking will be first to break down the site into how do I visualize, how do I go about looking at this site from an outsider's point of view, and from inside, what functions should go onto as soon as I enter versus upper level versus the top level. So once I figured out and adjusted to that, there is more important thing that I skipped, which is the regulatory requirements. So you have to, of course, abide by codes and regulations. So you have setbacks, you have height limitations. Sometimes in places like New York or Melbourne, you have limitations of what kind of facade you use, what kind of glazing you use, and which angle you use, and all this, because it creates affecting the neighbors. You shouldn't be affecting, your building should be good, but it should not be affecting your neighbors. So there are regulations to do that. So you have regulatory requirements. Then comes how you envelope your building. So once you figured out the programming, the areas to be kept, which levels and how many levels, and where your vertical connections are, which are called cores, and where your horizontal circulation is, how you enter and how you take different steps into the building. That once you figure that out, then you start looking at, that itself start to shape your building. The building form comes out of that inner thinking, and then you start looking at what sort of materials and which orientation. Now, north facade should not be looking exactly like south facade, because south has a lot more heat than the north. So these are the kind of things that we start looking at, the orientation and how we treat the facades.
Right, sir. Thank you, sir. Shriman from second year, sir. He is of the opinion that rather than double skin and static facades, he feels that dynamic facades would eventually turn into multi-layers and it is better. He also wants to know your opinion on that.
Yeah, dynamic facades are more fashionable facades than static facades, but they have inherent problem because they're dynamic. As long as there are moving parts in building, the maintenance becomes a cost to it. You might have seen Islamic Center from Paris by Jean Nouvel, which is one of those very dynamic facades that he created in 1990s. I think I have a picture of it, but this one, it's a fenestration. It moves by the solar. So by solar angle, it sort of creates and closes by itself and opens by itself, but it stops functioning within a month. And it stayed like that for the entire building life till now. So the dynamism that is created to function has not been achieved because the moving parts in the building. It happens many times because people think a lot more about, the buildings could move and then it could be very dynamic. But as long as it is done without maintenance, it's a great idea. But most of the times it goes, because moving means mechanical. As long as movement comes, you have elements from movement of mechanical items, and you have to then probably, if it is automated, then electricity comes into picture. So this is a problem. But dynamic facades, if you are, that's why what people do is static facades depend on what is the efficiency rate, what is the kind of solar time, the period that you're looking at to protect the facade from. What is the peak hour of sun radiance on the building? For example, is it from 12 o'clock to 3 o'clock peak period? You design it for that and you achieve your maximum efficiency rather than moving the buildings wherever the sun goes and you move the building along that. Other than that, it is more of an advertising tool for me. And the building is moving, and that's really something fancy rather than functional.
Shriman also asked, can Indian climate adopt the double skin facade or retain the same buildings as we have? That's the question. Can Indian climate also adopt the double skin facade?
Yeah, great question. As long as India is so big, it has, it goes through from Delhi climate of Kashmir to Kerala. You have a varying degree of climate. So as soon as you say Indian climate, can we do the double skin facade? I would say, what is the local climate that you would want to design it for? That's more important. So, for example, the climate in Rajasthan is almost as good or hot as in Kuwait. So definitely you would want to protect the Rajasthan hot sun to come into the buildings. But if you go to Kashmir, you would like the sun to come into the buildings. So it varies, and definitely they work. The facades work excellently with the climate. Whatever you're trying to do is trying to protect from the climate. So it's very basic. And double skins really adapt to this idea. And many buildings in Hyderabad, I know that they have started doing this.
This is one question from Professor Shiva Kumar, I suppose. He talks about what about the acoustic insulation in double skin architecture? I mean, is that a possibility to have even acoustic features, or what do you know about an acoustic insulation?
Yes, it is definitely an added advantage actually to acoustics so that the noises from the street are not transmitted to inside, because you are creating a buffer by reflecting that some of these sounds that are noisy sounds coming from the traffic or any other industrial areas. So the skin sort of creates a barrier to allow that acoustics to go inside. It's definitely an advantage. And some of these We have designed one which really is in a very noisy area, and then this is actually the shape of the facade is done this way so that it reflects the noise towards up, so that it's specifically so the noise is the sound is reflected upwards rather than coming into the building. So it is an advantage.
Fine, sir. I think those are the questions we have for today. At a professional level, though there is one pending on the personal level. If you can allow me.
That's the most important one.
The students of architecture, I mean, we are starting off on a in-house journal.
Okay.
So we're just starting off, and the dean has talked about you many a times regarding this. So students, I mean, this is BT who had the first college magazine of JNTU. It was called JNTU. He made this first magazine, and it was a complete manual, I suppose.
Yes.
It was a complete manual thing. There were no machines or there were no prints involved. It was a complete manual thing on and copies of carbon, I suppose.
Correct.
So and that was how it was. Yeah, I mean, Dean was telling us about this when we had this topic on discussion. And if there is something we would like to hear from you, sir, that journey, and also how do we go about it? If you can enlighten on that aspect also.
Okay.
Just a moment, Ajay.
Sir.
In fact, I have a copies of it, and I will scan and post it to students.
Yes, sir. Please do that, sir. If you had it now, we could have shared it also, maybe.
No, I didn't scan. Even I'll share it to BT also.
Okay.
Thank you.
I have a couple of magazines.
Okay. In fact, I continued this to School of Planning in Delhi. When I was there, we used to create a very informal magazine called a Spaghetti. There, it'd be SPAGHETTI. So spaghetti is like a mixed bunch of bag. So we used to collect all kinds of things and put into that, cartoons and whatsoever. Magazine in a college is, in my opinion, very important connecting tool to people, connecting tool to students, particularly to express what their feelings are about the college, what they believe, and if they are trying to communicate to others the way, and also the college communicates to others, the school communicates to others by way of putting a printed or a digital face to it. It is important in terms of continuing to collaborate. It creates a collaborative environment between students. There is no distinction between what first year student thinks about and what the final year student thinks about in that sense, because the magazine is a tool that brings all this into one platform. That is the real aim of a magazine, and it fosters people to contribute. Because when some of the very hardworking and very academic students come into starting this process, the others, I'm sure, whenever there is something new happens, and there are people who would try to stay away from there. But the magazine is something that actually brings in the people from that backbench, because they would be the people would want to come and then try to put things what they believe are right and what they want to communicate. So I would really suggest that you should start this, and wish all the luck. And I urge the students, particularly those who think the magazine is useless right now, those are the students who would come back and want to design the front page of the magazine. So I really would encourage the students, and my journey for that is really comes from my background that I used to do a lot of cartoon work right from my 6th, 7th standard onwards. So cartoon used to be an expression of what I believe and what I saw in the newspapers, or making it comical and humorous. Because humor is a great thing that you want to communicate. You want to win the enemies, create humor. You want to collaborate with somebody, create humor. So that used to be my tool, and it still is. There are many aggressive meetings that happen in a boardroom, but As long as it's humorous, you win the game. So your magazine should be open to all and take criticism, at the same time contribute and bring out the best of academic as well as technical knowledge the students are gathering. And it should not be something that, copy paste. It's very important. When you talk about things, when you try to imitate others, you should always give credit to the person that you're trying to say. This is very important for the students. We had many students who would just look at magazines and keep that facade is great and I want to adapt it. That's okay, but if you want to adapt a facade from somebody else's, you should look at whether that's really applicable to what you're doing, and give the credit to the person who has actually created that. That's very important. So in the magazine, it goes the same. And you want to do something, and you want to contribute. By the way, there are many literary folks within the students. They wouldn't come out, like poets, I'm sure, artists, cartoonists, and creating jokes, etc. They all should be open and put their finger onto this magazine. That's how, once you start that, you would gather a lot more momentum with others to contribute. No contribution should be small or big. This is the motto. It should be any contribution to the magazine should be evaluated. Of course, it's publishable. It should be published. And I wish all the best. And I think the Students' Council or some sort of a group that could form this and then and take it up front. And by the way, these magazines, so informal, could become real tools of change in many, many institutions. You might be knowing, MIT's student magazine is very well referred magazine. For example, it starts off a very informal magazine, but that becomes, if something is published in that magazine, people talk about it because it's MIT students magazine. So I wish, Woxsen School will do that.
Thank you, sir. Thank you. Definitely are aiming to do that. Thanks for those encouraging words to sir. With this, we end this question and answer session, sir. I would like to call upon Professor Ramakrishna Bhushi to say a few words about the seminar.
Thank you, Ajay.
Thank you, sir. Thanks a lot.
Okay. First of all, it is very, very excellent talk by both the speakers. I literally became a student and I jotted down very important points in this session. So after all, there is a great saying, a teacher is advanced student. People always say, a teacher is nothing but an advanced student. So some of the insights, again, I recollect here by both the speakers. Especially the Syed, he spoke on climate and women activity. Both should not be compromised. Very important point. And similarly, the process of innovation in architecture, that is very important area. And container building at low cost, quick construction, and without compromising the technology. And similarly, the energy saving by shaping the building. That is at the conceptual level. That is very important aspects. He dwell on that. Similarly, the BT, and he highlighted 3 points: communicate and express and speak out. When he spoke about the facades, it should communicate, express, and speak out. Very important aspects to be considered. Similarly, temperature reduction at each layer of the facades. Very, 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 very notable points he has highlighted in his lecture. So I once again thank both the speakers for a great sessions and a great insights for the students, not only for the students, for the faculty also. And I request both the speakers, please contribute your first article to publish in our magazine from the BT and the Syed. Please, sir.
I will.
Okay. Thank you so much. Once again.
Thank you for the opportunity and nice closing remarks. Sure, we'll do our best.
Okay.
Thank you.
Thank
you,
you.
Ramakrishna.
Thank you. Prasanna, over to you, Prasanna.
Yes, sir. Thank you so much, BT sir, for your valuable time and a great take on double skin architecture. It was a very interesting presentation and we have got to see a different perspective today. And we thank you for your great insights and also for our magazine inputs. We will definitely try to share our first copy in-house journal with you and as well as Syed sir. And on that note, I guess it's a wrap for today's session. But wait, hold on. Chandni, don't you think behind all these architecture marvels lies a great challenge in construction?
Of course, yes, but to listen more about challenges faced in construction, we will have to stay tuned for tomorrow.
All right, that sounds interesting. On that note, we would like to thank our speakers, Professor Syed Ahmed sir, B.T.Srinivasarao sir, R.Ramakrishna sir, Ahmed sir, Raul sir, Ajay sir, and all the audience for attending this architecture conclave. We hope you have a great day ahead. Thank you so much.
Thank you, sir.
Thanks a lot. Thanks a lot.
Thanks a lot. We'll sign off, please. Yeah.
Thank you. Bye-bye.
Suresh, you can end this. Thanks a lot.
Yeah. Thank you, BT and Syed.
Thank you so
We
much.
hope to see you tomorrow, sir.
Definitely. And no, BT and Syed, please join us
Please
tomorrow.
join us tomorrow for
Sure. Okay.
for a panel discussion also. And then
Okay.
Thank you. Bye-bye. Have a nice day.
Thank you, sir. Thank you.
Thank you
very
so
much.
much, sir.
Thank you all.
Thank you,
sir.
everyone.
shall we sign off, Prasanna?
Yes, sir.
Yes, sir.
Yes, sir.